A very warm good morning. I welcome all of you for the second day of National Convention of Mechanical Engineers. At the outset, let me invite all the dignitaries to take seats on dais. I invite Dr. Bhimraya Maitri sir, Dr. P.M. Padore sir, Dr. E. Rangareddy, Dr. R. Venkatesan, Mr. A.P. Acharya, Shri Milind Pathak, Dr. R.L. Srivastav, and Dr. J.F. Agrawal to occupy the seats on the dais. It's an honor to have Dr. Bhimraya Maitri, Director of IIM Nagpur, with us today on this second day of the National Convention. May I request Dr. Padore, Director VNIT, to felicitate Dr. Maitri sir. Thank you, sir. I now request Dr. N.T. Rangareddy sir to felicitate Dr. R. Venkatesan. Thank you, sir. May I request Sri Milind Pathak sir to felicitate Mr. A.P. Acharya. Thank you, sir. Dignitaries to please occupy their seats on the dais. In this fourth technical session, we are here for the memorial lecture. We have Dr. S.P. Luthra Memorial Lecture. Dr. S.P. Luthra, after a brilliant academic career in India, was awarded a Government of India Overseas Scholarship for Higher Studies and Research at Imperial College of Science and Technology, London. He obtained his PhD in mechanical engineering and then worked at Northwest Railway Mechanical Workshop at Lahore, Punjab PWD, Hydroelectric Branch, Shaw Valence and Company, Siemens India, and many more. Dr. Luthra has served as head of mechanical engineering department at Delhi College of Engineering. He was also the visiting professor at University of Wisconsin, USA. He later joined IIT Delhi as professor and head of the Department of Applied Mechanics and held the positions of Dean of Students, Dean of Examination, Dean of Faculty, Dean of Administration, and finally became its director. During his professional career, Dr. Luthra was connected with various professional, educational, and scientific organizations. He was a recipient of President of India Award for Best Teacher in Technical Education in 1979 and the prestigious award by Prime Minister of India for meritorious service rendered by the IIT Delhi on the occasion of Silver Jubilee. in 1986 and a silver medal by the President of India for meritorious services rendered to ISA Bangalore on the occasion of Diamond Jubilee in 1986. Dr. Luthra had long association with the Institution of Engineers, having joined it as a corporate member in 1944. He had served on the council for 12 years and was the chairman of Delhi State Center for Institution. He expired in 1993. In the memory of his dedicated service, the Institution of Engineers India instituted an annual memorial lecture in his name during the National Convention of Mechanical Engineers. We are privileged to have Dr. Bhimraya Maitri as the speaker for this memorial lecture. Let me introduce him to you. Although he is a big personality and needs no introduction, Dr. Bhimraya Maitri, Director IIM Nagpur, is a distinguished academician, researcher, and an astute administrator. An outstanding leader of management education, he has performed key leadership roles at many premier management institutes and corporate in his remarkable career. Dr. Maitri is a former director of IIM Trichy. Under his dynamic leadership, IIM Trichy has catapulted among the league of top business schools in India. He has also contributed immensely as Dean at L&T Institute of Project Management, Vadodara, IIM New Delhi, MDI Gurgaon, and leading research programs at BITS Pilani. A renowned expert in the area of project management and infrastructure, quality management and supply chain management, he has numerous research papers and books to his credit, apart from being on editorial advisory board of several national and international journals. Dr. Maitri is the visitors nominee at IIT Delhi, IIT Roorkee and IIT Jodhpur. He is also a nominee of Ministry of Education, Government of India on the Board of Governors of NITI Mumbai and NIBM Pune and Chancellor's nominee on Academic Council Gondwana University. Dr. Maitri was leader of two Indian delegations to Bali, Indonesia and Netherlands for development of international standards. Sir has received prestigious Ravi J. Mathai National Fellow Award. Also, he is the only serving IIM director to receive the country's prestigious AIME Keval Nohriya Award for academic leadership in management education. Maitri sir has also received Distinguished Service Award from Asia Pacific Division Sciences Institute, the Top Director Award by CSR, the Prerana Puraskar, Distinguished Alumnus Award, and the Top Rankers Excellence Award for Outstanding Academic Leadership. Currently, he is the President of ISDSI Global and member of Institute of Supply Management, USA. We welcome you, sir, and I invite you for delivering your lecture. I request other dignitaries to take seat on the audience side.
It is fine here. Anyway, so whichever you feel. Okay. Yeah. Very good morning, respected Director, VNIT, Professor Padole, the chairperson of this conference, the convener, and all the office bearers of Institute of Engineers, the Mechanical Engineering Division, distinguished professors, invited guests, my dear students. Today it is my privilege to be a part of Dr. S.P. Luthra Memorial Lecture 2023. A great leader, visionary, and he has proven as a role model in the area of mechanical engineering in particular and in general in the entire engineering fraternity. So I'm happy to be a part of this memorial lecture of 2023. So the topic is Industry 4.0 and 5.0. application for mechanical engineers. Now, if you look at the today's the volatile world, I say it as a fluid world. So in this fluid world, today we are moved from, in terms of mechanical engineering perspective, from industrial era to intellectual era. So the journey from industrial era, we are moving towards intellectual era. So if you see the industry 4.0, so if you see all the three prior to 4.0, the period between industry 1.0 to 1.2, it was in decades, many decades. But if you look at the industry 2.0 to 2.0 to 3.0, the difference is in decades. So from century to decades, so 17, 18, and from 19 onwards, so industry 3.0 to industry 4.0, the difference is very, very small. And if you talk about industry 4.0 to industry 5.0, the difference is in terms of number of years. So from century 1 to 2, and decades 2 to 3, and 3 to 4 is only few decades, and 4 to 5 is less than 1 decade. So this is clearly indication of that the disruptions are happening very often. The speed of change is much faster than the earlier. And even if you go according to one particular data source, what they say is before 2002, from civilization to 2002, and after 2002, 2 days data is much, much bigger in volume and size comparing to civilization to 2002 data. So this speaks a lot about 2 days data after 2002 is much, much bigger, and that itself speaks a lot about the disruption and its implications in this disruptive world. So therefore, from the transformation from industry 1.0 to 2.0 to 3.0 and from 4.0, if you look into that, each and every time there is a tremendous change. And from 3.0 to 4.0, if you look at that, that was the era of internet, that was the era of computers, and that was the era of, you know, connectivity, and also there is a depth of distance. Depth of distance means you can be anywhere, still you get connected. And you can see each other, you can talk to each other. So that is what industry 3.0. From 3.0, we have moved to 4.0. 4.0 is all about connected technology. Connected technology. So this 4.0 basically facilitating for productivity faster, cheaper, better, and at the same time, it has brought the tremendous change in the productivity and tremendous change in the basically the quality of life for the people in the world. So this industry 4.0, to talk about few technology, as all of you know today, each one of us can't live without AI, artificial intelligence. No, AI coined in 1956 in one of the workshop in one of the American college. Until 2000, nobody was knowing, but after 2000, now AI became a norm, and it is associated with each and everyone, those who use the mobiles and technology. If we talk about 3D printing, now, I was talking to somebody in L&T. They said they have built two houses. They have printed two houses in Bangalore. Two-bedroom kitchen in 8 hours. They can print a house. So that is 3D printing. And now the time is not far away to print a car. So today one car is made up of 14,000 components, and if 3D printing comes, probably few hundred components are good enough to print a car. So that is what the power of 3D printing. If we talk about cloud computing, so within no time, huge data can be processed, analyzed with today's the faster technology. Similarly, if you talk about and very latest, we are talking about Chat GPT, generative AI, and also if you talk about the today's latest the development of combination of IoT and AI, Internet of Things, and artificial intelligence. Now, between the two, IoT and AI, and the young intelligent people, so the interface of these three, people using AI and IoT, so they have power to change their ability. Using IoT and AI, people can change their ability, and the moment ability change, that will take them to next orbit, and that make them to change their behavior. So that IoT will translate into IOA, Internet of Ability, and from Internet of Ability, it will convert the person next level, that is IOB, Internet of Behavior. The moment all of you know that the moment you keep on adding your competency capability, automatically the competency comes, the confidence comes, and also inside you know the arrogance also build and behavior also changes when you keep on moving positioning power. So therefore IoT, it is basically your competency and capability enhances, and also and your behavior, the way you see the things will change. Even though eyes are same, but the way you see the things, different people see the things, and they will not say the same thing, but different people will see the different things. So this is a kind of intellectual era. From industrial era we have moved. Now, in this intellectual era, Industry 5.0, which is all about the collaboration between the machines and manpower. It is all about collaboration to machine, collaboration between the machines and manpower. It means Industry 4.0 is talking about using all those connected technology, and now Industry 5.0, it one step ahead, it is how to collaborate the machines with the human being, the people, so that each and every one can have a personalized experience and they can have personalized product. Now, personalized experience and personalized product means today we have digital twin. Now, digital twin can be used for number of purposes, basically for simulations and testing. For example, now we are mining here, or even whether it is a western coal field or any mining area, whatever the machineries and equipment we use. So those, whatever the life cycle of machineries are there, even productivity, what it comes, that can be simulation and testing can be done, and without any hassles, bottlenecks, you can once you simulate, once you test it, and you can go for execution and implementation very smoothly. And not only you enhance the productivity, it is faster, it is safer, and it is also less expensive. Earlier term used was cheaper. Now the cheaper is called as a less expensive. So less expensive, faster, and cheaper, it is possible because of the collaborations. Now, today's the latest one, probably it has come less than few months, we can say not in a year, that Chat GPT, what we talk about. So Chat GPT, you know that within no time on fingertips, whatever you write, it comes. So this is the way world is moving. And in between, probably you heard another term before Chat GPT and generative AI. That technology is all about the metaverse. Metaverse means virtual space. And one is a real world and one is an unreal world. So in unreal world is going to be more expensive, unreal world is also, you can purchase the space, you can do many things. So it is also called as a Web 3.0. So this is how all these tools and technology, irrespective of what branch of engineering, every branch of engineering, these tools and techniques are going to be utilized for the fullest extent for personalized experience as well as for productivity and for safer side. And if you look at the mechanical engineering from where it is moving, earlier industrial era, what I told, everything was tangible, everything was visible. You can, if you go to the any industrial site, people used to work on assembly line and product used to move and people used to do their job. Everything was visible. From visible, we have moved to this intellectual era. It is totally not visible, invisible. Invisible, but if you look at the output, the better output, the best output, we always experience and we get it. So therefore, if I give the example of the the Singapore Bank, the bank is not visible, its services are available for each and everyone, not only Singaporean, but all the people across the world. They have a great experience of having their account with the bank, and the experience is great even though they can't physically see the bank. So that is what intellectual era is. So in this intellectual era, all these tools and techniques of industry 4.2 or 5.0, if you put them together and combination of these two, and what the mechanical engineering field is going to gain out of that. So as I told you, there are number of benefits, and that benefits, if you put all that put together, 5.2 and 4.2 together, there is another term we use it as a cyber physical space. So CPS, cyber physical system. So cyber physical system means basically it is also sometimes people call it as a physical and digital. So today's we cannot live only physical and you cannot live only digital. So today we are in the era of physical plus digital. So physical and digital means that CPS, it talks about, it is a connection of the people, connection of various objects, various things, and connection of organization. So connection of people, machineries, information and organization. The four things are connected together with the support of cyber physical system. And that is going to provide the personalized experience, and also it utilizes full potential of the people in the field of mechanical engineering. So all the potential of people skill can be used, and their ability as well as their competency goes up, and in turn it will move all the organization to the higher orbit. At the same time, people also move their competency and capability. And today, as all of you know, that knowledge alone is not sufficient. Probably our time, we used to go to the college and school for the knowledge, but later on, people started going to college and school not only knowledge but also build the competency. And today and here onwards, knowledge and competency alone are not sufficient. These two are not sufficient. The students are going to the college or university to learn not only competency and knowledge anyway available in Google, but apart from competency, students are looking the college to enhance their capability. Now, capability means experiential learning. Capability means a phenomena-based learning. And this kind of capability building, these all the 4.2 and 5.0, they are going to a very, very significant role for capability building. And that capability building help each and every student in the field of mechanical engineering and also other engineering, because that experience, for example, simulation with digital twin, As I told you, digital tin is also used. Probably, you can speak in Marathi, but the front person can understand in, say, Japanese language or Malaya language. So your image, and again, lip movement in Marathi, lip movements are different. In Malaya, lip movements are different. But at the same time, the communication through this CPS communication happens such a way that people, those who are communicating with Malaya people in Malaysia, the lip movement will be exactly as per the Malaya language after translation. So this is a kind of a communication one can provide and connecting rest of the world. Earlier, people say that good communication is extremely important for engineering and professional, but today the software and this digital technologies have provided all those facilities. You need not to understand all the language, you need not be a competent for all the language, but still the communication can happen very effectively and efficiently. So that is where probably if you look into that national education policy 2020, the lot of preferences have been given to the local languages, the mother tongue. So that mother tongue, the creativity, idea, what you think you can express the way naturally comes, which is not possible, the language which is not your mother tongue. So that is going to be the advantage, and technologies are providing to provide the facilities to communicate people with different languages. So therefore, this industry 4.0 and 5.0, what are the challenges? The one biggest challenge till today or few decades back, the privacy was available, and in going forward, you have to purchase the privacy. There is no such word called privacy, and if you want, probably earlier, probably if you see that maybe 50, 60 years back, there was no separate zone for smoking in hotels and any other places. Today you have to go to where they ask also, you want to smoke or not, accordingly provide, because the zone has been provided. So in future going forward, probably we have to have we have to purchase a space for privacy. It is not available. Even though probably we are watching the TV, but the TV will capture all the items available, including items, gold and all available in your cupboard. So that will capture, and if it is a Chinese mobile, probably it goes to Peking, its headquarters. So such a kind of information, or even if you are in the market, probably the information system is such a way that your eye movements based on that you can be caught. So that is what AI, and most probably you might have heard about our deputy CM when he went to Japan. Very recently, he has announced Nagpur there is going to be a AI R&D center. Government of Maharashtra is planning to set up here, and all those things are without going to those places, they are captured through this artificial intelligence. And probably you need not to go, you need not to have huge manpower to capture all those illegal things. They can be captured in sitting in your own offices. And today, if I talk about, I was consultant to New Holland tractor, and New Holland tractors, most of the Punjab farmers purchase those tractors, and its headquarter R&D, this what it is called, the control room is in Greater Noida. But when farmer is plogging or using the tractor in the farm, immediately in the control room they make out that there is a problem in the tractor. Farmer will not any experience any problem. Farmer is using the tractor, but at the same time control room they will come to know there is a problem in the tractor. Immediately they call to the farmer, during your lunch break our mechanic will come and set it right. And during the lunch break, control room, whatever the data they captured, they go and they set it right without any break in the productivity. After the lunch, again the farmer keep on using. So this is how today's technology, remote control mechanism using sensors, you can repair. And New Holland tractor is the one lifelong services, free of cost services. So it is their responsibility to provide all those equipments and machineries with maintenance free, and maintenance will be taken care by the companies. So this is the kind of technology we are in, and therefore in mechanical engineering, the kind of development, even if you look into that, because mechanical engineering is the one field out of so many engineering, when it comes to all the new technologies, new advances with respect to industry, always mechanical engineering has been the forefront. And if you look at the out of all engineering, the most laggard one is the civil engineering. They are the last one to go for the technology or automation. And mechanical is the first one. And from mechanical engineering, people use the terms and also tools and approaches, techniques. The faster ones to replicate from manufacturing or mechanical engineering was the computer science. If you see IT industries, all the terms and the tools of mechanical they utilize when IT field came into picture, or IT or computer science came into picture, many of the terms of mechanical have been borrowed and used over there. And that is how those who are the first one to use the technology and those who are first one to capture the technology, they always remain in the forefront as a role model. And mechanical engineering has been since historically forefront, and today computer science has taken that lead over the mechanical. And today all engineering field, now they are following whatever the new tools and techniques coming in information technology that has been used for mechanical engineering, it has used for all other engineering. But earlier, front seat it was with the mechanical, and today it has taken over by the computer engineering. So this is how the mechanical engineering, and earlier the boundaries were very clear: mechanical, civil, electrical, electronics. But today, boundaries are getting blurred. So whether you talk about any engineering, for example, I head the All India Council of Technical Education, Executive Council and Board. So we have taken decision now. Everybody knows AI and ML. Everybody needs to know whether it is a mechanical, civil, electrical. All students, they can even minor more than one major mechanical, minor AI, or minor ML, or many other fields. They can get into that. Those kind of the the multidisciplinary kind of approach, because everybody needs this ICT or this disruptive technology or advanced technology. So that is what today we are moving from a very highly specialized area to a multidisciplinary kind of thing. And T-learning is going to be extremely important today for the new generation engineers, those who are studying in engineering colleges. To build new India, they have to get into a multidisciplinary approach. And for that purpose, T-learning means they should be having specialization in one or two areas. That is a vertical one. And the top of the T, the horizontal portion of the T, that they should be knowing many things which are in general in nature. So that is what T-learning or multidisciplinary is going to play a very, very important, because you should know what is its impact. Probably in today's context, mechanical engineering, so for example, if I am teaching a course, how to achieve the efficiency in fuel consumption, then it is not only sufficient to teach how to fuel consumption can be reduced in different approaches. You should also look into the other perspective. That is what multidisciplinary. Another perspective for fuel efficiency, one has to look into how to look out of the box, how to redesign the engine so that fuel consumption will tremendously come down. So this is the way. One is a traditional thinking, one approach. Second one is the out of box thinking, second approach. And all of you know that today the General Motor 110-year-old company is afraid of Tesla and Google, driverless car. Now, earlier competition used to be all the passenger car industry. Competition used to be only passenger car industry. And you all know that the history of Maruti Suzuki's success, 1983-84, it started in Gurgaon, then Prime Minister, and Krishnamurti was heading. And Krishnamurti, by the way, the person who built three great companies, Maruti Suzuki Steel Authority of India and BHEL Trichy. So that when Maruti Suzuki came into picture, and still today they maintain more than 50% of the market share. Out of the top 10 cars sold in India, 6 models belongs to Maruti out of their 16, 17 models. So this so many decades continuously maintaining the lead in spite of Tata, Mahindra, Volkswagen, Toyota. And if you look at the Suzuki, in Japan, Suzuki is not number one. In Japan, Toyota is number one. And globally, Toyota and General Motor, they compete for one and two. But in India, Toyota Kirloskar combination is nowhere with Maruti Suzuki. So this speaks a lot about their systems, their processes, their innovation, and in spite of in this modern age, they are the first one to remain relevant. Maruti Suzuki supply chain is one of the best supply chain in passenger car industry, and that is where even Thailand disturbance happened, or in Japan there was a tsunami and nuclear power and many things got affected, but Maruti immediately they took a decision. Not only first tier, second tier supplier, they follow just in time within 10 to 15-kilometer radius. All their supplier located, and their inventory is just 2 hours, just in time, every 2 hours, and it is not stored anywhere. That is only stored where it is to be used. It means there is no special storage space. And and if you see the figures of Maruti in 2007, every 26 seconds, any one of the two plants, Maruti Suzuki and Manesar, they used to produce one car. 26 second one car, any one of the two plants. But when you see the 2010, the 26 second reduced to 16 second, any one of the two plants, one vehicle is ready. So that is the speed of Maruti, and they succeeded because they were the first one to think of innovation. No vehicle will go empty and come empty. That was the principle they followed. And when they used to supply the all the finished car for marketing purpose, then when they used to park in Agra for distribution to other part of the India, while going they tied up with, in those days Usha Fan was one of the big industry. They used to get the empty trucks from Delhi to send the finished car to Delhi and other part of the northern part. Then Maruti tied up with them. They understood, tied up with them. You pay us half of that, and our vehicle will come to Agra, and while going back, instead of empty, we'll put your all the fans we put into the our trucks, and we unload at Delhi. So this is how, while going and while coming full load. So third party logistics, even the small suppliers in 3P, third party logistics. So one truck is good enough to take the item for 4 5 suppliers and supply it in just in time 2 hours in Maruti. So these are some of the aspects. As and when technology changes, they were the first one to capture the technology, use the technology, and remain with relevant. So today's world is how to remain relevant, how to remain relevant, and also apart from remain relevant, because somebody has very rightly said, wise look at the future, fool look at the present. So remain relevant is, it is looking at the present, but you also look at the future. 3 year down the line, what technologies are going to change. 3 year down the line, what things are going to disappear, what new things are going to come. Now everybody is clear, everybody talking about EV vehicle, and now everybody is getting ready themselves to compete in the market of EV vehicle. But if you look at the Gauranga Das Prabhu, who has set up the sustainability, spirituality, and social impact center 90 kilometer from Mumbai, Wada Taluka, Palghar district. He is training the Adivasi students how to repair the AB vehicles. You can see how futuristic thinking he is about. AB vehicles are yet to come, but he's training the Adivasi students in in Wada Taluk how to repair the EV vehicles. So this is how the time has come, how to make sense or sense making for 3 year down the line, 5 year down the line, how the things are going to happen, how, and we have to be ready today. So that is where it is important to remember. Somebody has rightly said, yesterday of tomorrow is today. Yesterday of tomorrow is today means today we have to act. Tomorrow results will be there, and we'll be the role model for rest of the people. Today, all of you know that Satya Nadella is considered as a great sense maker. Sense making is one of the qualities. It is required those who want to lead the world. Perpetual learners are going to lead the world. So therefore, all the time you keep on learning, because the speed of change of technology is happening very fast. If you can't touch the same river water when you go second time, it means old is not dead, new is not born. We are in catch 20 situation in this disruptive world. So the moment you get into the new technology, before you develop your learning curve in that, next disruption happens, and you have to leave this, you have to capture that, and again you have to leave. So this is the world, we call it as a, this world, only certainty is uncertainty. So only certainty is uncertainty in this kind of world. So to lead in the area of mechanical engineering, or in the corporate world, important thing is the sense making, to remain relevant to the world, and also empower the people, young people. Reverse learning is extremely important in this world, because the younger the people, more knowledgeable and more they are competent and capable in the newer and newer technology. So therefore, empowering the people, the time has come now how to listen to the young minds and learn from everybody. Multi minds are better than any one of us. That is most important. And the extremely important for all Indians, particularly, somebody has said that Indians are known for contextual. European and Americans are known for the concept and model. So anything, everything, they always look into the concept and model. But Indians, the context is known. Given the context, Indians can do wonders without using any concept and model. SWOT analysis, 4 Ps, 7 Ks, all those things are not required. So you remember when tsunami happened, Naveen Patnaik, Orissa, within 2 days he restored. But when America tsunami happened, they took 2 years to restore, because they believe in concept and model. Somebody will collect the data, and somebody will do the survey, and somebody will analyze, and somebody will implement. So Indians are extremely good as a contextual leader. Today, context is changing because of disruption. So in changing context, contextual leadership is going to play important role, and that is where how to deal with the context, Indians are good. And that is where, if you look at the Silicon Valley, top 25 companies in America headed by Indians, because they are good in contextual. So therefore, to become a contextual leader, it is extremely important. And Indians are good in context. It is not because of we study in all the great colleges and universities. We are good in contextual because our parents and grandparents have taught us Indian knowledge system, Indian traditions, Indian values, and that makes us more, in sense making. That makes us, that develops a sixth sense. So therefore, Indians are playing a key role globally, whether it is education institutions or any industry, because of this one. So therefore, contextual leaders are extremely important. Another thing which is important for Indians, a teamwork. So people say one Indian is equal to three Japanese when it comes to performance, because we are extremely good in performance. In given the uncertain situation, we can do the wonders. We can be a game changer. But when two such Indian come together, our performance is half of the Japanese. So we are extremely bad in teamwork. Coming together, two people, performance is poor, but one individual, we can do wonders. Japan's success lies 1980 to 95, 15 years as a super economy in the area of Japanese, all known for manufacturing, Germany and Japanese. They succeeded because of the teamwork, because of the group work, Kaizen or quality circle or lean. All those things, all those concepts are through teamwork, and they succeeded. I think India needs a teamwork and collaborative work. Industry 5.0 is all about collaborative work. It is not only collaboration with the people, it is also collaboration with the people and machine. So therefore, it is extremely important. When I was in MDI Gurgaon, visited Maruti plant, there 60% robots and 40% people working together in link. So therefore, it is extremely important. Deloitte study says out of 1200 behaviors of the human being, 65 behaviors have been already incorporated into the robots. Now, robots are replacing all the routine jobs and autonomy or automation, whatever you call. So, robots are also added these 65 behaviors of the human beings. Now, there are 1200 behaviors. Very soon, robots may also equipped with all 1200 behaviors. And then how to collaborate, how to work with such robots, such smart robots is going to be very, very important and challenging job. Robots till today, they are not going on strike. But there is a competition held in Korea. Four countries participated the competition, game competition of robots in four countries. Now, the way competition we do among the teams and colleges now, the robots competition is happening. Robots are sitting on the boards of the big boards of the manufacturing industries. Robots provide the unbiased data to take a fact-based decision making. So this is the kind of world we are in. So therefore, the forward going, how to critical thinking, active listening, and remain relevant to the current world. Apart from all these things, extremely important for all of us and including mechanical engineering is we live with the Indian ethos. So these are the 4 5 things extremely important, and for that purpose, many times we only work for what to do. And today time has come, you have to also think about what not to do while working out what works and what doesn't work, and what to do, what not to do. And the most important thing today's world is not only learning and live learning, unlearning. Unlearning is not taught anywhere. Those who unlearn successfully, they stand out in the crowd and they capture the new technology faster than fast. So the assumptions, beliefs, what they are today, they are not going to be there tomorrow. So that is where, and extremely important in this world is a leadership, and the leadership which is defined by our great saint of India, Swami Vivekananda. That leadership definition is leader is the one who thinks the unthinkable, who achieves the unachievable, and who sees the invisible. Such leaders are need of an hour to lead the industry from the forefront. And probably, if you look at the Sunil Bharti Mittal, when you acquired a big loss-making company, or Tata acquired Jaguar, which was much bigger in size and volume than Tata. Lakshmi Mittal acquired Arcelor, which was much bigger. It means small fishes are eating the bigger fishes in India. So, it, so today time has come. Competition, from where competition comes, we don't know. It is not necessarily from our own sector. It may come from anywhere, like Google and Tesla are giving to the auto industries. So in this kind of uncertain world, it is extremely important, look within, look around, and look beyond. Thank you very much.
Thank you very much, sir, for enlightening us with your kind words. Unlearning is really very important, and you have touched our hearts by telling us how important it is to unlearn the things so that we can move on and learn new things. Thank you once again. Our next speaker for today's session is R. Venkatesan. Dr. is an IEI. Hello. Hello. Let me introduce Dr. R. Venkatesan. He is an IEI Council member of Mechanical Engineering and established IEI Kanchipuram Local Center. As a founder chair, he is serving as a technical consultant, senior scientist grade at National Center for Coastal Research, Chennai, an adjunct professor at the University of Massachusetts, Dartmouth, USA. Dr. Venkateshan has served as a senior scientist G and program director at the National Institute of Ocean Technology, Chennai, and served under the UNEP Regional Seas Program in Sri Lanka. He is Fulbright awardee from USEF and Chartered Marine Technologies, UK. He worked with international collaborations with USA, Japan, Bulgaria, UK, South Africa, and many more. He is a member of Tamil Nadu State Coastal Zone Regulatory Authority, Government of Tamil Nadu. He earned his PhD from Indian Institute of Science and completed courses in marine environmental pollution and management, international business management, PG diploma in maritime law in Dr. Ambedkar Law University. He has served in various capacities in United Nations Organization in UNESCO, IOC Paris, WMO Geneva, United Nations Environment Program, UNEP Nairobi. He visited Arctic and installed India's underwater observatory. This is very interesting, sir.
Thank you.
He has traveled to 40 countries and delivered lectures in many universities in USA. He established real-time data reception center with instruments deployed at sea for monitoring cyclone, tsunami, and developed various technologies. He has to his credit 180 papers, 10 patents filed, 4 awarded, guided 6 PhD scholars, has delivered 500 invited lectures, and 10 of his products technologies are transferred to industry associated with technical societies. We are really privileged to have such a great speaker with us. Thank you.
Thank you very much. Thanks a lot. Uh, Good afternoon to everyone. At the outset, I thank the past president of IEA to ensure that I come over here and make this presentation. It's really a very august gathering. I just listened to a very interesting lecture of Dr. Maitri, and what an extempo speech and continuous flow. Really amazing to see someone, and I'm glad to spend some time listening to that lecture and took a lot of points. Maybe I'll use it in my next lectures. And I was talking to Dr. Acharya, really an expert you have in the field of oil industry, and we are sharing a lot of information. And today I'll be just covering to you on some topics. And I gave this topic, and what is the role of mechanical engineers? Today this is a challenging time. I go to many colleges. There are some colleges, the course is getting dropped. However, the mechanical engineers, they come into the different discipline. You have research, develop, design, and test and improve. This is what is all about mechanical engineering. It was rightly pointed out, Dr. Maitri, is that many of the terminology, including computer, we call machine, that come from mechanical engineering. I'm given 20 minutes time. I'll slightly rush through that. Kindly cope up with that, and I may give some newer terminology. Try to use it and learn more with Google search and things like that. This particular clock talks about today what we are talking. Even the Secretary General of United Nations, he spoke very clearly a few days ago that days have gone. We are not meeting the requirement of 1.5 degree. It is really going to be 2.1, 2.2 by 2100. The measures taken by various countries are not sufficient. You can see the disasters. We can see the various changes what is happening globally. You can see the temperature changes. And sustainable development goal, the recent study clearly speak that we are not at all following that, including the one related to life below sea, which is more related to me. None of the goals are achieved. We are not in right path. However, as a role of engineers in taking this climate change, there is a committee constituted by NRC in USA. They have brought out the first one could be on critical materials development. Second could be on the sensors and sensor development, sensing technology. Third could be enabling and exploiting artificial intelligence. It was really spoke about what is the need of AI. So this is the way mechanic or engineers, all the engineers have to work towards that. Even mechanic engineers have a role placed to that. When you talk about technologies, I would like to share some experience as mechanical engineers. There is a need at which we have to look differently. This is a desalination plant working for the past 15, almost 18 years. It works on a low temperature thermal distillation process. You know very well water boils at 100 degrees centigrade, 1 atmosphere pressure. The water could be vaporized by reducing the pressure. So this has been studied in Charles Law and Boyle's Law. We have studied in college, in school. where in Lakshadweep, in half a kilometer distance and half a kilometer depth, you have cold water. So you take the surface seawater and vaporize in 20 millibar pressure, maybe smaller than this room size, and this vapor is condensed by drawing the cold water. Naturally, if you want to make the water to be cooled, you need a big chiller. That's not, there is no need. In the nature, you have this. Why can't this be duplicated? Unfortunately, close to the mainland, like Indian subcontinent, we have to go far away. That is the only one difficulty. This has been working. Now the fishermen, the local people are operating it. Till then, the society were not getting the fresh water. They were using the only salt water in the bathroom. Today, they are able to get that. Next is on energy aspect. Yes, ocean provides various scope like wave, ocean thermal energy conversion, and also gas aid. It is nothing but methane gas below the seabed, or even land also there is available. And offshore thermal plant, yes, the government of India has brought out a policy. Currently, two plants have been places have been identified. One of Gujarat, Jakau, one near Ramanathapuram. The present day data sets are being collected in a critical way. That will be another scope for us to go. I was part of an ocean thermal energy conversion where the plant was constructed. I was a project leader. Now, next I thought we have been very happy to know about Chandrayaan, where next, and we are also going toward Aditya, going towards Sun. There's another one which Government of India has taught in. Man knows more about top of the moon than the bottom of the earth, what he's been living. This is what is a challenge for us. How do you send the man down below seabed? There are man submersible available already. You know very well. Alvin is a submersible which has gone dive down and studied this Titanic shipwreck. There are submersible available in China, France, as well as in Russia. And we are the one will be joining that elite group, wherein three people will be sent in over there. As a mechanical engineer, what are the challenges we see? I thought I will share with you. This is a complete breakout system which we are getting being developed in India. We have the important point is titanium shell, where the man has to three people have to sit inside and proceed over there. There are subsystems like any human nature. Like I was talking to the Airbus people, and they were telling that 40% of the cost of the Airbus, 60% for the testing and other appliances. This is what anybody when human carrying is there. The testing aspect is important. Herein, we have broken into that human carrying buoyancy. Buoyancy is nothing but flotation of the system under water. It is negative buoyancy is the one which is getting submerged, and positive buoyancy making it up. So this buoyancy need to be done. There need to be an emergency method by which the whole thing can be brought up. The control and navigation, the control system, yes, mechanical engineers need to play a major role. And power and propulsion, finally, life support system. This is what is important because the carbon dioxide release has to be evacuated. So we have broken it, we have brought into that, and we are working. There is also another important point as a mechanical engineer, you should know that there's a pressure balancing is required in the oil fill system, which we are doing it in a smaller level in smaller equipment. Pressure down is very high. At 5,000-meter depth is 500 bar. These scuba divers can go up to 30 meter depth. There's 3 bar pressure. More than that is not possible for us, or the human blood vessels get collapsed. How do you make sure that system works in case of equipment? If it is there, how this has to be balanced? We use a technique called pressure balance oil fill system. By this, the sensors are kept over there. The selection of material for the shell is very important. Titanium 6Al4V ELA grade is chosen. Why ELA grade is extra low interstitial material is required? Because when the whole sphere is drawn in, the defects can come in one corner, one portion, middle part of it. So the currently available many of the manned submersibles are made of titanium alloy, wherein we are also working on titanium ELA grade. There is also a maraging steel one system is there, but the problem is with the titanium to marriage in specific gravity is 4 times more. It becomes more heavier for us to handle. I happened to visit one of the submersible which is under service in Woodsole Oceanographic Institute in US. I happened to sit inside and work on it, and they were maintaining it. This is a submersible which have died down in Titanic shipwreck. More than 5,000 times it has died down in the last 40 years, and now they are refurbishing it. Next, it was really pointed out by Dr. Maitri that what is the role of mechanical engineers on IoT and mechanical engineering, and the ANML linked to mechanical engineering, and cloud computing and cybersecurity in mechanical engineering. These are all linked to that. It's going to be an interdisciplinary exercise wherein your expertise is required to look at all these aspects. There's going to be an advancement. There's need of IoT linked to mechanical engineer. Innovation and societal need is one aspect which you all need to look into that. I'll go in depth. The innovation comes, we can broadly divide into 4 categories. The data innovation, digital innovation. We know what we are going through the data and digital innovation. There's going to be frugal innovation, which we see Jugaad, where we see smaller techniques are being used. How do you bring that? This ingenious technologies, we have smaller solutions we have found out. The frugal innovation is one thing which need to be captured and brought in. Finally, societal innovation. Societal innovation, whatever innovation you do, that should reach the society. Once you have, okay, your business angle, next you need to have a personal satisfaction. We all have come to the earth. We have come to this position because of the society. Now you have to give back to the society. That's one area we can think as an engineer, we should always say. Catalyzing the mechanical engineering innovation to address the climate change. That's one important aspect where you as an engineer need to look at that. You talk about when you talk about carbon removal, when you talk about carbon storage, water management, energy storage, and greenhouse gas. This is one important thing, greenhouse gas emission. Many of these innovations have come from science. We only for our need, like Mahatma Gandhi said, we got everything for our need, but not much for our greed. We have been having comfort. Our population has increased. We were 5 billion. We crossed the 6 and 7. Now we are heading towards much, much more. If you cross through that, how do you cope up with that? Our requirements are increasing. We talk about ozone layer hole, and the one thing we have got those particular type of gases used for refrigeration. We have changed. So everywhere there is a need. I'm also linked to Ocean Technology Conference in going to be held in Malaysia, where more than about 2,000 industries come over there. They are talking about how to use the ocean or how to use the big oil companies for carbon storage. Now, when you talk about carbon sequestration, ocean plays a major role. 70% of the earth, what we live, consists of ocean. If the ocean did not exist, earth would have been warmer by 70, 80 degrees. Many of the living organisms would not have existed. Even we would not have existed over there. Now, when you talk about the transport sector, the amount of carbon dioxide released is captured by the ocean. The ocean has got tiny plant called phytoplankton that is capturing it. Now, there is another problem we are having is ocean acidification. That's the pH level of ocean is increasing or changing it, mainly because it's getting not changing, mean acidifying, mainly because of capturing of carbon dioxide is increasing. How do you do that? There is a technique being mechanical engineers are evolved in US. How do you remove that? But this is one aspect. Other aspect, there's always a talk about not to disturb the nature. Anything you disturb the nature with a limited knowledge, that has got a larger repercussion. There's two school of thought over it. But again, water is a big crisis. There is a definite report I will show with you how the water crisis is going to play a major role. Greenhouse gas, methane gas, SOx and NOx emission. We all know about what is happening on the land and what is happening into the ocean, how this is being transported. That is being talked about it in a bigger level. So this is in climate change in nutshell. We know very well what is happening. You will be surprised to know that I was talking to my friends in Spain. Like we remove the shirt in the month of May and June, they removed the shirt and came out. They have never felt it. Highest ever temperature rise happened in the land as well as the ocean. It happened in May June of this year. This is not at all expected in the southern part of Europe. Next, you have erosion. The coast is increasing. The governor in San Diego, he has invested a lot of money to protect the coast. Even in India, many past parts of our Indian coast, including Kerala, lot of coast is getting eroded mainly because of sea level rise. The IPCC reports clearly says that by 2100, 10 major cities, coastal cities are going to be affected if at all the same thing continues. Again, you need a technology. We talk about disaster. One of the study recently brought out in 1958 in Alaska, there is a highest amount of 1,700 feet of water has increased. If this happens today now, the coastal population is increasing, the infrastructure is increasing, it's going to be a disaster. As I said, temperature of the sea and the water management. The report by the United Nations clearly talk about water scarcity. I was also talking to the experts. The groundwater, what we are drawing, may not be able to have these structures on the earth to be there. That's another crisis we are facing to that. Then again on carbon ocean storage and plastics, biggest enemies. That is our own need. I have published the first ever paper 20 years ago. If you Google search in Great Nicobar, how the marine plastic has come there. Today it has gone on a big level. Everywhere plastic, even in atmosphere, deep ocean, Arctic, we have got plastic everywhere. There's an alternate material to be there. Is the industry prepared for that? There was a survey conducted. Yes, many of the CEOs said, yes, we know very well climate change is happening, but the industry is not prepared to that. For all these things, innovation engineering only have to find a solution. That is what we are talking about it. If you talk about innovation, this is one of the things which I always capture. And how many components are there? We talk about 1894, how this sewing machine was brought in. Maybe please see, I'm not able to run the video because of paucity of time. Fantastic machine which was brought out by innovation. In those days, how the casting was there, how the machining was there, how the components were assembled, how the integration has taken place. There's no word to say in the simplest machine what we use, the innovation which has been brought in over there. This is another picture. We have studied about fluid dynamics and Bernoulli principle. Whatever you study in college, Bernoulli principle or Newton's third law, there is a different way of application over there. This is what innovation talks about, that how do you find solution. This
Heavy
is
duty
another work
pedals jostle a
where
grapevine to break
voluminous.
grapes free.
Yeah, maybe, yeah, you can see how in agriculture
Why
technology we
stores get
need innovation there. There more changes are happening. I'm also part of a committee in TH Technology Innovation Hub in IIT Bombay, wherein on agriculture technology, various projects we are reviewing. I'm working very closely with them. We all are part of this Maharashtra. You know very well, onion is, we are one of the first or second largest to produce there. Except 3 months of a year, we are producing continuously. But unfortunately, 40% is lost, mainly because of three ways the onion can get spoiled. One by how hard it is, another one is by smell, another one is by color. Now we need to devise a sensing methodology or technique and help the farmers or forewarn them. We need to tell them about what is happening in forecast. In case of a change in temperature, in case of a rainfall, we need to inform them in local level. This is what various projects, there is also a collaboration between India and US, and the IIT Bombay is working on it. I'm glad that things are being brought to the level, and I also always say that ingenious technology of the farmer need to be captured. They are working on it. This is another area where mechanic engineers need to work hard. Next, when you spoke about plastic, the microplastics have come into that. We know very well they are all covalent bond. Even though somebody says that plastic will remain 1,100 years, 200, it's not there. It's going to remain. It's a plastic footprint we are going to leave, particularly in the ocean. When you leave, there's no way that it will get removed. But there are ways, there are even challenges happening, there are competition happening. How do you clean it? This is one innovative way where in air bubbles, this particular river is clean. You need to think. There's going to be a big talk about that. I'm part of various committees. 1,600 rivers globally bring major amount of plastic into the ocean. By 2050, it is estimated that plastic will replace ocean and the fishes. Now, another thing is that I also work on biomimic, trying to understand about the nature. You can see how these animals, including the birds, they are able to fight, they are able to co-locate themselves, they are able to communicate and say they don't collide each other. This is another interesting part. You can find simpler solutions from the nature on the innovation, what you look at it. You have to look at it in a different eye to find it in a different way. This is one work we are trying to do, that duplicating the biomimicking. We have developed a biomimic fish. We have operated in the ocean, but it's a big challenge for us. How does the energy stored? How did the energy? We are still not able to understand. Unfortunately, we are not able to get the material. Of course, there are various models are available. You can buy and assemble and test it. This is the only area where you can start thinking about that. And these are all some innovations we have done in the limited way in the field of ocean technology. And it has reached the society. To work in the ocean is very complicated. Only once in a year you can go. Whatever you develop, you have to find in a way that there could be alternate way to work. So redundancy we bring out. These are all some product we have patent during my tenure. Another, my involvement here is involving students. I've been working with students, and I also run Marine Technology Society and many other things. Herein, the student developed their own underwater robot, and the winning team we used to sponsor and send it to San Diego in USA every year. I only coined that in 2011. IIT Bombay team had won, and they reached up to the finals, competing about 56 college and university. Why I'm telling here is that I'm sitting the other side, many of the professors will, it's the degree is fine. What more we ask, what more comes by this involvement. That student who had worked in this particular project, Microsoft in particular year gave him highest package in IIT Bombay, mainly because of this involvement. Like Dr. Maitri spoke about collective leadership. How do you work together, developing a product? Something you are sending to the space, something you are sending to the water is different. Only one difference is water. The water ingress is the biggest challenge for all of us to work. Your seal is imperfect, the whole thing gets spoiled. So this is what they have learned. There are about 25 AUVs, and they are all working in different competitions and competing in different colleges. They go to Singapore, they go to Europe. There is also a startup, 160 billion dollar company. The startup has come up to that. They are working for underwater cleaning. They also do it in Middle East. So since small level, what we have started grown, I'm happy that this is growing in a bigger level. There is a more need. There are more newer thinking is required. It's nothing but application of your knowledge, and making it work underwater. That's all the difference is all about. Now, this is a book which I wrote when I was running an Indo-US collaborative project with 15 institutions in the US and 15 institutions in India. We studied about Bay of Bengal, how the rain comes on the monsoonal studies, where many of the mechanical engineers they turned into oceanographers. And when I visited University of Rhode Island, I'm happy to see that the book was brought out by the librarian and showed it to me. Amount of about 1 lakh books, my book was seen and it was part of their curriculum. This is what happiness we have, whatever it reaches the students. These are all some work what I have done with United Nations. And just to show you that, finally, to conclude, I spoke about involvement of the society. There was a cyclone which is really 70 lakh coconut trees of destroyed, and we happened to see a family of two women, one at 80 and another one 60, mother and daughter. They were renting on about 10 coconut trees. Then we start on a small level. Why don't you give $1 a tree and it's for 2 generations? That's the idea we coined. Few of us, we are not NGO. We were still working in government, but I'm happy to say that 20,000 coconut trees were given. We visited about 30 schools with our own money. Till now, the trees are safeguarded by them. It's growing about fourth year now. Every year we take video and give it to the donors, whoever had given the money. So you initiate, start doing something to the society. You'll always come and get a support from everywhere. And this is to show, this is for students, whoever is there. What you see here, what is happening in this video, commonality of people. This is what is the purpose. Dr. Maitri also said, why do you come to college? Why do you come and study? It's not the degree alone. You get something else out of that coming to the college. What is the commonality of this? Anybody can tell? Okay. You keep seeing that. They're all individual like us, but something is there with them. The skill. That is what he also said about skill and competency. We need to develop skill. Everybody has got different skill. What is our skill? What is our strength? That need to be looked into that in a different perspective. You can see in your walk of life, different people are there having different type of skills. So skill development as you get educated is very important in the respective field. That will be applicable anywhere. Next, skill versus various knowledge. They talk about technical expertise. They talk about problem solving skills. They also got attention to the detail. They also got communication skill they develop. And finally, the time management. They talk about adaptability. Finally, continuous learning. You can see my case at the age of 58, I wrote an examination in maritime law, and it was really horrible to say write an examination 3 years and 3 hours writing examination. But still, continuous learning is very important. Even now, I am learning in the oldest language called Tamil. It is about 3 BC, about 1,500 years old language, which existed before Tamil. Most of our ancient literature was written in that. So, creativity. Creativity is one aspect which has to come, that is going to remain with you forever throughout your life. So, creativity is very important. For all these things, you need to have a continuous effort and activity. So, takeaway, climate change, individual and the community behavior alone can make the change. Whatever we are talking it, individual has to change, the community has to change. This is what INAF talks about that. And first, every individual has to change by self. Like Dr. ABJ Abdul Kalam said, individual changes, then the house, there is a change, then there is a street change, there is a village change, then lead to the district, then the state, then to the country, then to the global or nation. So the changes are very important, what changes we take, and we become a pro-planet people. And finally, as an engineer, it is a multidisciplinary approach is required. Innovation and emerging technology and simple and specialized knowledge is required, particularly for the society who are deprived of living far away from us. We are all gifted people who are able to come over and live there. There are many more who are not gifted. Let us go and do something for them to the society. Let us make this planet safe for living. That's what sustainable development talks about that. Let us leave something good for the future generation to live. Thank you very much.
Indeed, a very interesting presentation, sir. Thank you for throwing light on the climate change and role of mechanical engineers. We understand how we can serve in a big way for the betterment of our society. Thank you again. Our next speaker is Sri A.P. Acharya, Senior Vice President, Indian Oil Sky Tanking Private Limited. Sir will be speaking on the topic Journey of IOSL. Sir A.P. Acharya has 35 plus years of experience in downstream oil and gas business spanning functions in sales and business development, profit center operations, planning and scheduling, organizational growth initiatives, key account management, logistics, distribution management, and general management. A team leader who effectively meets goals through strong, decisive executive leadership and interpersonal communication combined with sound practical management style. He has worked at HPCL for 25 years across all business verticals as Director BD Fuel Asia and Southeast Asia for service provider based in Dubai and is currently the Indian Oil Skytanking Private Limited since April 2013. He has profound knowledge about the entire value chain involved in the aviation fuel management system at airports and is actively engaged as a business driver for the company with very strong operations management and general management skills. He has a master's in marketing management from Jamnalal Bajaj Institute of Management Studies, Mumbai, and BTech honors in electrical engineering from College of Engineering and Technology, Bhubaneswar, Odisha. We welcome you, sir, for your session. Thank you.
Thank you very much for the introduction. And I must certainly say, I have been in the august presence of my previous speakers, Dr. Metri and Dr. Venkateshan. There are a lot of learnings, and I must laud the extempore speech given by Dr. Metri and the uh, wonderful insights into various climate change initiatives that is being taken by Dr. Venkateshan. I was also talking to him on the sidelines, and we're exchanging a lot of information. Uh, as an industry professional, yes, it is a very humbling experience to be in the august presence of academicians with so much achievements and so much of contribution to the society, though we also do a little bit in our own way in our own industry. So, I will be speaking about the aviation fuel management at airports. The company is basically associated with that, and how it has been changing. It's a changing paradigm, but I will run through it briefly because of the paucity of time. I will basically focus on the three aspects of the theme of this seminar to see what we do in our own way. About the company, we are a joint venture company of Indian Oil and Sky Tanking of Germany with equal equity participation. And we are an independent service provider in the area of aviation fuel management. Now, if you look at prior to 2006 or 2008, the airports, which were typically run by Airports Authority of India, had all the three oil marketing companies or four oil marketing companies providing fuel to the aircraft with their infrastructure and manpower. Post privatization, the thought process changed among the private players to bring in international best practices because giving land at four different parts of the airport, which is a scarce resource, is going to be a challenge for the airport. And they thought, why not give land at one place, develop a common facility, let allow somebody to operate that on a non-discriminatory basis so that the freed up land resources can be utilized for more commercial purposes. So that is how the open access system came in, and that was the first time when it came in India in 2008. We were fortunate to be building the first open access airport at Bangalore. Since then, we have not looked back. We started in 2008 at Bangalore, and we started as an open access model. Then we went to operations and maintenance services. So the company is now basically into fuel storage and hydrant management. We are also providing fueling to aircrafts. We basically do a lot of DF bot projects, that is design, build, finance, operate, and transfer projects, which are typically a long-term concession of 20 to 30 years. And we also give engineering and advisory services. Our core focus is basically to bridge the gap between the seller and the buyer. The seller is the oil marketing companies and the buyer is the airline. And so we are basically an independent service provider in this field. Currently, 2008, we started with Bangalore. Today, we are present at 32 airports in the country in different business models, depending upon what opportunities have come our way. We handle roughly about 330 million liters per month. This is the quantity of fuel that is being handled across our network, and we are fueling, one flight every 72 seconds across our network. We are involved in DF projects, O&M services, engineering advisory services, and we have a strength of about 650 plus trained employees. And we are continuing to growing. So today you can see we are present from north to south. We are also operating the highest airfield in the country, that is Leh. The most remote location is the defense base close to Pakistan border, Thois. We operate that facility too. So this is just a small brief journey to guide you through. 2006, the company was formed. 2008, we established presence at Bangalore. 2010 at Delhi. 2015 at Mumbai. Then 2020, we won the best aviation service provider in the company by FICCI organized Wings India. We won it subsequently again in 2022. As of 2023, or as I speak now, we are there at 32 locations, and rather in a couple of days, we will be taking over 2 more airports under our operations. And it is a proud moment for all of us in the company when we won the DF bot concession for the upcoming airport at Noida, because that is going to be in its final phase, going to be the largest airport in the country, and we have got a 30-year long-term concession to build the entire aviation fuel management system there and also operate it. Just to run you through an aviation landscape in India, the country has about 131 airports. Now, airports are basically categorized based on the business model, because post 2006, the government of India, which all airports were being run by Airports Authority of India, they have started privatizing airports. So today we categorize them as there are 15 international airports which are run by Airports Authority of India. There are about 6 under public-private partnership, which was acquired by Adani very recently. There are JV international airports, which are 7. Then there are state government international airports or private international airports. One is Sirdi and one is the new Goa airport. These are known as the state government or private international airports. Then there are customs airport where there are customs for export, import plus passenger movement. Then there are domestic airports. So as of now, we have 131 airports, and Ministry of Civil Aviation or the Government of India has tremendous impetus in this aviation sector, and we plan to take it to 200 airports in the next 5 years. That's the target. So just to give you a brief about how the things are here, you can see ATMs. ATMs is air traffic movements that talked about a landing and a takeoff. So you can see the number of flights that take off or land in the country. I'm comparing this with pre-COVID and our current status. You can see the recovery has been almost, we have exceeded the pre-COVID. So India was one of the countries in the world which recovered post-pandemic at a very, very fast pace. Then we have 327 million passengers. Just think of the opportunity that is there in this sector with a 1.7 billion passenger, 1.7 billion population. This percentage is a very low percentage, so you can imagine the amount of scope there is in aviation if you are able to connect each and every corner of India with airports and make flying affordable. Then cargo movement and the number of fleet. What fleet is being shown is what is available now with the Indian carriers, that is 710. But the the projections are like this: by 2024, we will exceed pre-pandemic passenger traffic. There will be 200 plus airports by 2028. By 2023, 2037, there is a projection of 520 million passengers, and we will be having somewhere around 2,500 aircrafts owned by Indian carriers. These are the projections. Coming back to our field, aviation fuel, you can see how the demand is going to change, and for current year, the demand is somewhere around projected to be over 8,600 TMT. This is what the demand is going to be as far as aviation fuel is concerned. As far as our company is concerned, our focus areas are these 6 major areas: operational excellence, safety, quality, learning and growth, customer service. Last but not the least, continuous improvement. Because continuous improvement is only going to bring about a change in achieving our targets for OE or operational excellence. So as far as smart manufacturing is concerned, we do a lot of predictive maintenance, And using AI and sensors, we are trying to predict, because the fuel farm is a the fuel storage or the activities which we do are highly safety critical, because we are handling a petroleum product, and it's also a closed system. You don't see the product outside, unlike petrol or diesel, which you can really see. Here it's totally a closed system at airports, because from the fuel storage the product is pushed by underground piping system to the airport. Not that all the airports have underground piping system, which we call it as a hydrant refueling system. Most of the airports have this, particularly the major international airports, and the product is pushed at a pressure of 120 to 150 psi. It is available just below the aircraft wing, and a vehicle or a dispenser or a dispensing equipment just hooks that and delivers the fuel to the aircraft. So when you are handling a complex fuel storage, and fuel storage at airports of bigger size can somewhere be around 50,000 kl to 60,000 kl. That is the size of the fuel storage. So a lot of artificial, as of late, AI is being used for monitoring the entire setup, how the operations are happening, and people are able to other typically in earlier what happened is that there used to be somebody who is moving around on a regular basis around the fuel storage unit to see. Now what we are doing is using artificial intelligence in all our aspects of operations to improve efficiency, to improve safety standards. Similarly, Internet of Things is a critical component that allows multiple systems to collaborate through a distribution control system. And we are now slowly trying to apply AI to it, so that we are able to sense, or we are able to see things or predict things beforehand, so that even before something can go wrong, we are able to visualize and address it accordingly. Data integration, this is another area where we are looking, because typically what happens, and smaller airports it is manageable, but in, larger airports like Delhi, Bangalore, Mumbai, where the number of flights that are getting fueled are somewhere around anywhere between 400, 500 in a day to somewhere around 700. Delhi, the number of flights which take fuel on a daily basis about close to about 600. Bombay, it's about close to 500. When we are going to do so much of flight fueling in a 24-hour cycle, then what happens is we need to use lot of data in terms of uh, in terms of AI, in terms of IoT, to bring data so that there is an effective scheduling and planning. Because today you will appreciate at airport when a flight is delayed, all of us you know get a little perturbed, get a little disturbed. Similarly, on time performance is a key parameter for all the airlines, and very often it is the service provider at the ground who is responsible for the delay. There could be minor technical snacks in an aircraft, but if an aircraft is delayed, be sure one of the service providers could have failed. Okay, because in a short turnaround of 45 minutes, you can imagine fuel, the aircraft has to take fuel, the aircraft has to load passengers, baggage, do the cleaning. So there are so many activities, and the area around that is a total chaos. Every service provider trying to complete their activity within a small time or a limited time period. So what we have done is we have implemented a i6 software where all this data is there. So what happens is that we collect all this data to plan our resources and also see what is the fuel it's going to take. Ultimately, the fuel that is going to be operated is going to be decided by the airline. But we also get data to see how efficient we can be. Automation and robotics, this is picking up in the industry, though in India we are yet to start, because what we are looking at fuel farm, we have already started this automation, and in terms of using AI for our fuel farms and other things, for receipt, and having distribution control system for monitoring the activities. Because at larger airports you will have pipelines connecting to the airport storage. There's a pipeline from refinery to airport storage, from airport storage to the tarmac, and all the systems sometimes run parallelly, because larger airports where the consumption of uh, uh, ATF, like in Delhi, has a demand of aviation turbine fuel of 7,000 kiloliters every day. So you can imagine the operation of pipeline, because 7,000 kiloliters of product per day consumption being moved by road bridges is just impossible. So you have pipelines. There are two pipelines connected via refineries, and they continuously feed the airport. Similarly, the airport operates 24/7. The entire hydrant refueling system is operated. So what has happened is we have automated many of our functionalities to give us warnings in terms of any aberrations that may happen in the operating parameters. Even at the airport, in the hydrant refueling system, if there is a pressure drop, abnormal pressure variations, then uh, these sensors are there, and we immediately get to know about it for corrective action. Now, use of robotics. Typically, these days also when tank cleaning is going on, because these fuel storage tanks which store fuel have to undergo tank cleaning on a particular cycle, typically 3 years. The entire storage tank has to be drained of product, drained of sludge, and then cleaned to see the interiors are intact. What happens today is we spend in labor, and when labor goes inside, it's a confined space. Within the confined space, he has to work with some traces of toxic gases or smell. So nowadays we are looking at robotics to enter and do the cleaning, and also check the interior coatings for any pitting on the surface of the tank, or on the surface of the epi coated tanks, or some pittings. So robotics can be used, or is basically starting in the industry elsewhere for tank cleaning, tank painting. Instead of scaffolding, you can have robotics for painting. Then we are also having nowadays, for this is a new thing which has just been introduced about a couple of years back, in a fire drill scenario, where it is not possible physically for the person to go and in close proximity because of the heat radiations. So now there are robotics or robotic firefighting equipments which can go very close to the area to throw water or foam. So this is another development which is taking place. Coming to renewable energy, I think Dr. Venkatesan talked about climate change. Dr. Methi also talked about how you go about Paris Agreement 2015. I think the International Civil Aviation Committee and the International Maritime Organization are left out in that agreement. That agreement basically talks that by 2050, we should not allow the temperature of the earth to go beyond 2 degrees. So it's a 2-degree path. Those efforts are there to bring it to 1.5%. So there were 3 goals set. And today, if you see, India was also a part of the Paris Agreement. And since the government has committed for that, now what has happened is there is an agreement signed. So the 3 goals which were there, we have crossed. We are now in goal 2 phase. We will soon be reaching goal 3. But this 4 pillars of this commitment is basically technology, operations, infrastructure, and market measures. So this, if you see, is the curve at the point. So with the current way of operating up to 2019, though the industry has worked without any much changes, what has happened is 8.5 billion tons of CO2 has been saved since emission has been lowered since 1990. If appropriate measures are not taken and the trajectory goes up, which is shown in the red, that then we will continue to go in that. But now that corrective actions are being taken, so what is going to happen is we are coming towards 2050, where the 50% carbon emission reduction will be achieved in the aviation industry. So today, India government of India with the airlines have signed an agreement that this is going to kick off in 2027. So in that, all airlines have a commitment to start using sustainable aviation fuel. That is to reduce carbon emission. So by 2027, the airlines in India will start using sustainable aviation fuel, starting with 1% blend, and maybe move over to 10% blend by 2030. So this is the target, but lot of work, lot of challenges needs to be done, because if you see in Europe and US, particularly Europe and US, SAF use has already gone up to 10% or some place 30%. Rather, Emirates has operated an aircraft with 100% SAF. Whereas in India, we are yet thinking. There are some talks happening regarding SAF. There are challenges as concerns. how do you produce SAF? Where do you get the feedstock? Where do you have a refinery? There's a lot of costs involved, and I understand IOC is thinking of setting up, Indian Oil is thinking of setting up a 3,500 crore investment project in having a SAF refinery as an additional project at their Panipat refinery. But the challenges are there because SAF is going to be expensive. Whereas as far as airlines are concerned, since 42% of an aircraft's operating cost accounts only because of fuel, so they are very cost conscious as far as fuel is concerned, and SAF will come at a premium. So these are the challenges in which the industry is still discussing. We have also been discussing as to at our Bangalore facility or maybe at Jewar facility, which is upcoming, how do we bring in SAF and support the airport in its initiative to be carbon neutral. They have also got their targets to be at some level as far as this reducing carbon footprint is concerned. Hydrogen is another fuel. Now there are people in the world who are looking at hydrogen fuel cells, because if you see the aircraft fueling equipments, we go to the aircraft. Rather, an aircraft fueling equipment is nothing but a heavy vehicle with on which is mounted aviation components. They operate, the diesel is engine is being operated because we draw power from the diesel engines to operate hydraulic and other mechanical systems. So we also have been thinking how to reduce, because it's not only a cost to us, it is also emitting lot of carbon dioxide at the tarmac. So one is hydrogen fuel cells, but there are certain challenges. It is being looked into. The other was looking at EVs. Uh, in the world as of now, I think so it is Shell and another company who have introduced EVs on a trial basis to see whether EVs will give the desired efficiencies in operation of an aircraft fueling equipment. We in our own way in-house, we developed a solar powered hydrant cart. If you see this small cart, it is taken by a jeep. It is towed by a jeep near to the aircraft, then placed below the aircraft. There are solar cells on the roof, and the entire thing operates. I wouldn't say it would be delivering fuel at a very high speed. Typically, we deliver fuel at a speed of in the 3,000 liters per minute. This we have tested this on 19 flights. It delivers fuel at about 700 lpm, and the cost of operations have come down drastically. But the major part is that we are not operating on diesel. We don't burn diesel fuel. Then advanced sensors. Yes, in our system, we have started about advanced sensors in various places. Since underground piping systems are typically 3 to 4 meters below ground level, there are sensors, and we are now, those are tightness control systems or advanced sensors, but now we are trying to implement AI to it to see whether we can improve upon those operating parameters. Dr. Methi talked about 3D printing or additive manufacturing. There are emerging trends now in 3D printing or additive manufacturing for aviation fuel components, not only for aircrafts but also for the fueling equipment which we are using. This will only bring in about more efficiency and try to save on the fuel consumption. Mechanical systems, diagnostics, advanced and okay, this is I talked. Advanced material. This is also being used because today each and every aircraft manufacturer is trying to look at how to reduce the weight of the aircraft to see what alloys are there, because if the weight of the aircraft is reduced, it becomes more fuel efficient. It is going to burn less of fuel, because the heavier the aircraft, the heavier is the consumption of fuel. If you see Russian aircrafts, they are by and large very heavy and they are fuel guzzlers. From a business point of view, we are very happy when we fill a Russian aircraft because he will take more fuel for the same sector. But if you look at a Dreamliner, it will take much lesser fuel for the same sector. So aircraft manufacturers are also looking in terms of different alloys, how to reduce the weight of the aircrafts. Digitization development, we have tried to digitalize all our processes to the extent possible and have started doing AI, integrating AI to that. So along with AI and IoT, so what we have done is, few things we have done is that our job nature is a very monotonous job. Okay, for years together, an operator would be doing the same job. So he tends to develop complacency. He tends to develop, a sense of nonchalant attitude saying that even if I deviate from a standard operating procedure, nothing is going to happen. I have been there in the system for last couple of years, having done no. What we are now doing is, whenever some incident, accident has happened, we have done a root cause analysis to see complacency or the attitude is what matters. So what we are now doing is that we have tied up with NetRed at Bangalore to use artificial intelligence to study his iris movement, his facial expressions to understand when his fatigue is setting in, whether he is overspeeding at the tarmac, whether he is tailgating, basically to see his driving behavior. And the feed is given to the shift office where the operation is being controlled. So if there is an alert for a particular driver, he is immediately called up and said, okay, wake up, or you are drowsy, take a break. So we are trying to use this. Same is the thing we are trying to do as far as tank farm is concerned for adherence to PPE. Very often as human beings, we have a tendency, there is a standard personal protective equipment which we are supposed to wear and we tend to forget. Sometimes I may wear a ramp jacket, which is shown here, but I may forget to use a glove. So today what we are using AI to generate an alert in the control room system. There is somebody out there who is not wearing the proper PP. It is for his safety. So it's basically enhancing safety standards. Leak identification and thermal identification regarding fire protection. I have already said a few words about it, so nothing much to add to that. Only thing is that AI is getting integrated with this to predict any changes, so, to highlight any changes so that a predictive action can be taken rather than waiting for the incident or the thing to occur at the for the thing to occur. So basically what we are doing is one area where we are working, we have had a couple of rounds of discussion with a vendor at Bombay, is looking at a VR simulation. All of us know that pilots undergo hours and hours of simulation before flying an aircraft. So when he is flying an aircraft, yes, maybe he is doing it for the first time, but he has seen the whole thing through a simulation module. And that is done so that you know what happens when you are simulating a thing a number of times, it gets ingrained in our system. Now, when we are training people, which takes about 4 months for them to develop minimum competencies for fueling an aircraft, we take 4 months because send him on aircrafts for fueling. What are the precautions he has to be taken? So today we are working on a vendor to look at a VR, look at a virtual reality module, and we are also telling him that not only you create a virtual VR module, integrate AI so that when he's wearing that headgear and doing the simulation, it also captures other emotions, facial expressions, whether he's irritable, whether he is there's some psychological changes, or how intent or how keen he is. So his commitment level to do something so that we also take corrective action for training him appropriately. We have, over a period of time in the last couple of years, we have started digitalizing all our activities to the extent possible. And right, sorry, right from the operator doing an aircraft refueling to each and every activity, it has been digitized over a period of time, and we are in the process of upgrading those for efficiency in the system. Now, aviation in itself is not inherently dangerous, but to an even greater degree than sea, it is terribly unforgiving of any carelessness, incapacity, or neglect. With this, I conclude my talk. Thank you so much.
From ocean, you took us to the sky, sir. It was an awesome information, data, and statistics about aircraft, sustainable fuel, and other operations. Thank you very much. I extend sincere thanks to the speakers, Dr. Maitri, Dr. Venkateshan, and Mr. Acharya, for their superb lectures. We break for the lunch now and we meet again at 2 p.m. Thank you.
Hello, can you hear me? Hello, sir, can you hear me?
Check. Hey. Check, check. Hey. Sir, are you audible? Kohli sir, can you audible? Sir, are you audible? Kohli sir, are you audible?
Hello. 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 Hello.
Sir, can you hear us?
Hello. Hello.
Hello, sir, can you hear us?
नाही पण इकडनं तरी काय येत नाही ते सोडून दे पण आताच ते आला पाहिजे.
Check, check. Kohli sir, are you audible?
A very good afternoon to all the dignitaries present here. I hope you had a fulling lunch. And I would like to invite Shashikant sir, Vivek Deshpande sir, Shivastav sir, Agarwal sir, and E. Ragganreddy sir on stage, please.
You are getting my voice? Hello? हेलो हाँ अभी आप बोलिए उधर से आपका आवाज पहले आता था अभी नहीं आ रहा है
Check. Sir,
We are
आ रहा है?
honored to have you all here on stage.
हाँ now your voice is
ठीक है सर, ओके.
Um, can you hear us, sir? So we welcome you all. We would like to invite E. Rangareddy sir to present Shashikant sir with a token of love.
okay so your voice is not coming to me now
Can we please have Shivastav sir to present Vivek Deshpande sir? Can we now have Milind Pathak sir to present Manoj Daigavane sir, our moderator for today's event? We are honored to have you here, sir. Now I hand over the mic to Dr. Manoj Daigavane, sir.
Hello. Very good afternoon. So I welcome all the dignitaries and respected members in this August House. Topic of discussion or for this panel discussion is challenges before entrepreneur, startups in mechanical engineering because of artificial intelligence, industry 4, automation and changing global digitization. So before opening, I welcome Today's speaker, Ravindra Kolhe, NBT Innovative India Private Limited, Pune. Engineer Shashikant Chaudhary, co-founder Babyverse, 10x entrepreneur, TEDx angel investor. Engineer Vivek Deshpande, founder director, Space Food Furnitures Private Limited. So before proceeding or proceed further, I would like to take view of every expert on the topic challenges before entrepreneur and startups in mechanical engineering. So first, Shashikant sir.
Thank you, Manoj. Uh, I think this is very interesting times in terms of like uh, even the startup world. Uh, if you really look at the intersection of the real-time data, IoT, Industry 5.0, which is now, of course, after 4, and then if you talk about the AI/ML, which is a part of artificial intelligence, in the almost like $64 billion have been invested in almost more than 5,000 companies. That's the space which is really exploding uh, in terms of the usage of the these kind of technologies into any entrepreneurial world. So it's not restricted to mechanical per se, because what they are saying is that these kind of technologies which were available to the big companies earlier and they were very costly, but because the technologies have become cheaper and almost like on a boxed kind of a tool set, they are getting available to the industries. Even the smaller industries can leverage these kind of technologies and create that kind of efficiency which can really sort of like give sort of like nullify the advantage of the big companies which they had on the smaller companies. If you look at the McKinsey report, even the McKinsey report says that if you take peer-to-peer comparison, the the companies who are adopting this AI and ML and IoT and those kind of technologies will fare almost like 4 times better than uh, the companies which are not deploying or using these kind of technologies. Because the rate at which this is happening, it's a very interesting data point. And that one of the data points says that by 2024, the entire human brain capacity will be available for $1,000. By almost, if you add 10 years down the line, 15 years down the line, then we are saying the entire human brain capacity would be available at 1 cent. Then they are saying by 2049, the entire human race brain capacity will be available at $1,000. And then they are saying you add 10 years more to that. So we are talking about 2058, 59. The entire human race brain processing entire world or race is going to be available at 1 cent, which is essentially telling the trends that the cost of deploying this kind of solutions is decreasing day by day, and it will become more and more easy for the companies to deploy right at the input level, right from the design level to the production level to the manufacturing level, but almost getting to a level where you are getting into a smart manufacturing state. You are getting to a stage where you are trying to, because at the end of the day, we are serving the customers. And if you are serving the customers, what is the new battleground? And the only battleground which is now being played at, the new battleground is extreme personalization. The kind of the personalization that can be given to individual customer to that level. And extreme personalization is going to be a new battlefield. And more the data you have, more and more insights you have, more and more predictive you can do, you are in a position to able to serve your customer much and much better. More and more data you have from the market, more and more data you have from all the ecosystem players, it is easy to analyze that data and correspondingly adjust the input side. So these are the kind of the trends which are going to be happening. And I believe the challenges in terms of deploying these kind of solutions will go on further reducing in terms of the deployment cost. So that's my take on the challenges.
Vivek sir.
First of all, let me first thanks for calling me here and sharing the days with one of the most learned inputs that I am able to learn here also. And thanks, Shashi, for enlightening on these details about AI. So basically, I am a mechanical engineer. Doesn't know, I don't know much about the details which Shashi has given, but definitely one fact which definitely comes to mind that really is it time to think that these are challenges or these are the opportunities which are coming up to every mechanical engineer from the perspective of and who are into manufacturing or sales or any field of business. So I feel AI, ML, and data sciences, which are the very new things coming on the horizon and which are yet to be deployed in our kind of setups, which are like small MSMEs or small manufacturing units or people who are not able to deploy those amounts of funds. And that's why they are feeling that these things are not in our reach as of this point of time. And it may take longer time for us to reach that particular levels. And during that particular changeover period, it may not happen that we are eaten up by the mega companies or so that we won't be able to handle the situation. So that threat is definitely there with each and every mindset. But if all of us take this as an opportunity instead of challenge and try to take little baby steps towards implementation of these aspects in their own perspective of business, definitely I feel these threats or challenges can be converted to opportunities. Thanks.
Kole sir, am I audible? Hello? 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 Yeah. May I? Yes, sir. Yes, sir. So, may I have your first opening remark on the topic challenges before entrepreneurs, startups in mechanical engineering because of artificial intelligence, industry 4, automation, and changing global digitization? Thank you, sir. Acharya Chanakya, the greatest economics, once said, if you are looking for a knowledge, give up the hope of finding comfort. Okay, sir, you continue. Okay, sir. Atmanirbhar Bharat, the flagship program that has worked wonders for our country, has done exactly post innovator out of worked wonders, post innovator of their comfort zone to make life easier for others and to cater the demands and requisitions of the localized global desi who want everything. The wisdom of Indian knowledge system wrapped in an attractive packaging to maintain and sustain the ecosystem and to be a global citizen. With this note, I will start or from again Shashi sir. Can you talk about companies you have invested who have leveraged AI or Industry 4?
Yeah, some of the companies I have practically seen and I have invested. One of the company, and if you see the trend also, the trend is happening like that. If you take any field, any domain, be it a mechanical, be it a health tech, be it insurtech, any particular domain or any particular product, it's more about the technology in the product that has grown. If you take the sort of like progress of medical field, what's the medical field progress? Progress is more about the technology which has gone in terms of making that progress happen in that domain. Even if you look at the cars, cars as a manufacturer, and the GM has clearly said that we are we have stopped manufacturing the cars for the drivers. We are manufacturing the cars only for the passengers, which means there's a lot of infotainment, a lot of automation, a lot of all those kind of electronic stuff. The component of the technology inside the car, as they say in the Mercedes also or BMW, it's like almost like a car on like 450 microcontrollers. So what is happening is the trend in terms of miniaturization, the cost, it is becoming affordable. The sensors, not even the sensors, we can talk about even the computers, as we were mentioning that the whole computer with respect to the size, its processing power, its RAM and serial outputs is going to be available in the next 5 years in 10 rupees, including the sensors, which means not only you will be able to do the edge computing at the place, but you will be able to sense the data, take the decisions right there. And on those lines, some of those companies which I invested was Car IQ, which of course been acquired by a company out of Khandesh now. And what they were doing is analyze on a kind of a board. They were analyzing almost like 250 parameters of the car, and depending upon the parameters, they would be able to judge what's the condition of the car in terms of what's the kind of the driver rating. Is he accidentally braking? Even he can come out with the rating of the roads, for that matter, because he was analyzing the daily pattern, and on all almost like every second basis he was getting those parameters and feeding it back to the system. One of the interesting IoT 3D printing based product which we invested is again from the VNITs, which the VNIT alumni is funded. So we funded almost like up to 1 crore to this startup called as Lucid Implants. And what the problem they are solving is the mostly the crania or mandible implants. Mostly the crania and mandible implants are done by reduction. What do you mean by reduction is there are titanium sizes available. So titanium implants for a nearer size is being taken, and then it is reduced to fit to a jaw, whether the jaw has gone bad because of the cancer or because of the accident or something has happened to the brain. But what happens is even if there is a millimeter deviation, the symmetry of the face gets defigured, and that's a lifetime. Now these guys have developed a unique way of using the peak material, the new material, and also developed a process whereby they are developing these implants to almost like microns to that extent. And they are, most importantly, they are doing that at 1/50th cost of what US does. So if the same implant, if you want to take in India or US, it might cost you something like around 50 lakhs to 75 lakhs. And they are doing it in 1 to 1.25 lakhs. That's the kind of the 3D printing kind of the stuff. Even it has the power to change the model. One of the companies again from VNIT which we invested was, the name of the company is the charcoal desk. And what he created was the first kind of a desk. We talked about it. That's a kind of a desk he came out. And desk is a desk for that matter. But what he has done is put the technology inside it. The technology inside it now knows, because of the so much of mineralization, he was able to put that kind of technology, which means now he is able to know how much time you have sat. Okay, what's the time you should get up, what's your gait, how much you are leaning, and all those things. It knows your productive windows and it knows your unproductive windows. It will tell you this is the time to get up and take up a walk. What he has turned is a very interesting aspect. He has turned a normal consumer product into a health product. And this is possible again because of the technology. So what the technology which has gone into a traditional product, be it a table, be it a executive table, or be it a car, or be it any kind of a product, those are the kind of place. And even the people are able to change the models with the company which again is again from VNIT. And I'm glad to say that these are the VNIT companies which are taking this place. What they're trying to do is changing the business model. Instead of uh, you have the coffee making as a service, what they're saying that there be a model where the air conditioning as a service. So the can you change the business model in terms of like the capital expenditure versus what they're trying to do is analyzing every parameter of the ACs right now, which are the heavy component, 20-30% of the energy cost is driven by the ACs. And if you can control that cost, what they are able to set up the business rules and able to apply those business rules over 1000 ACs. So that example wise, at night for evening 4 o'clock across the India, all the ACs would operate at 24 degrees. Nobody would come at 18 degrees or 21, or somebody would put it like 28 degrees. These are the kind of the innovations people are doing using the IoTs, including the kind of the 3D printing kind of a technology. There is a company out of uh, uh, IIT Delhi, again from VNIT, Rajesh. And what that company is doing a kind of an automated drone kind of inspections, not by a single drone, but by the single operator. The 20 drones can fly the different facilities, cameras on the six and bars of this drone, almost 4 drones and 6 cameras per drone. You can take 24 feeds, and that they are able to analyze the entire process, entire inspection, entire progress, just not by just creating a PDF file, but going beyond that. These are the examples where drones or IoTs or 3D printers or this kind of AI technologies the people are putting inside the startups. So these are just some examples related to the mechanical side.
Vivek sir, in this scenario, would blue collar jobs totally eradicated? Blue collar jobs totally eradicated?
So normally mechanical engineers are supposed to be blue collared. So we should not be threatened by all this. Basic thing what I feel about is all these new generation tools which are like AI, ML, everything is based out of data points. Unless and until you have a huge amount of data available, it cannot take any decision, right? So blue collar job, it's impossible. Like kal hum, if you want to, all of us, we are humans, and what all AI, ML, these are all robotic technologies, and we need food to eat, we need to sleep, and for having the food, we'll have to grow the this thing in the fields and the farms. So वो थोड़ी AI करने वाला है. So this is a basic thing. We all of us should be clear that there is no threat in terms of blue collared or the intellectual of the human in terms of AI, ML, whatever is coming. But definitely, it's a challenge so that every human being will have to be on toes to learn and acquire new things, new technologies. AI can tell you about predictability of your business process, about your manufacturing process, about your machine, the maintenance time. It can predict or it can give you the data about the efficiency, the productivity of a particular machine. But that doesn't mean that the work AI is going to do. For doing the actual job, like if AI tomorrow predicts that this particular machine, this particular shaft will have to be replaced, but that replacement, the person who is having a blue collar, he will have to do it. So basically there is no threat in terms of that. But as we see the overall development which is going on, like today, last 6 months or a year or so, we are all exposed to technologies like chat GPT and all, which are giving. So what I feel, the complete human brain is taken out, and everything whatever required is available on a click. So there is definitely a threat in terms of mediocrity, I would say. If people who are just mediocre in the system, they are under tremendous threat. If they do not upgrade themselves, it is going to be a big challenge for them in future.
I'll just take a one step. What happened in the agriculture, that's going to happen in the manufacturing sector. In agriculture, if you see by 1900, we had 40% labor, and then it got reduced to almost 2%. What's going to happen is the job displacement. It's not that they're going to be eliminated, but as Vivek, you rightly said, the people will be required to have the higher set of skills, and they will be deployed there. The routine, repetitive, manual kind of the things which can be done by normally the kind of the robots or those kind of things which are going to be becoming cheaper and cheaper. There is no doubt on that. The cost of the technologies is going to come down as we are talking about. So that's where the people will have to move to little higher plane in terms of the higher productivity jobs. That would be my take.
Rightly said that continuous upgradation is required. And now I will go to the engineer Ravindra Kolhe sir. Sir, my question is, what are the effects of AI on mechanical engineering business startups as they deal more in manufacturing?
So I think, especially from the mechanical side, uh, the what I what we are trying to see, which is happening in the humans also now, is creating the digital twins. So digital twins of the machines as well as the digital twin of the process is being created, and wherever the whole simulation can happen on the digital twins as to what will be the effect actually on the ground. what I what I also see is that a lot of things in terms of like we the most of the AI works on the classification techniques, but the generative AI is a kind of a different genre where it helps you generate in terms of like the kind of usage one can think of, or rather that is happening right now is in terms of the kind of the material that is going to be required, right? You can define the properties. These are the kind of the properties I would require for a particular electrical vehicle. I want more of a magnetic kind of thing. I want more of a conduction. I want that more corrosive kind of thing. And instead of getting into a serendipity, they can find out and suggest the kind of material that can be needed for that particular product. And that's going to be a newer way of looking at how these AI technologies are going to be. And that in terms of, even if you look at the interesting aspect of in the workflow which is happening in the industries, if there is a conveyor belt, if there's a bucket elevator, if there are all those kind of assembly line movement which is happening, every assembly line unit has a particular cadence. It works with a particular speed, and one feeds to another, second feeds to another, and third one. And moment there is a loss in a minute, for a minute in the assembly line, because of one unit of the assembly line is not working properly, or it is out of sync, the cost could be in the tune of $25,000 to $30,000 per minute for the bigger companies like this. But now what big, the AI is doing, or because of the analysis of through the IoTs and the sensors, I can know now the fractional change in the speed of the units also. So not only at a larger level, at a unit level, even that there is a change in that cadence of a particular assembly line unit in terms of the speed, I can quickly know whether I should stop or whether I should take the corrective action. I mean, if you look at even the classification, uh, defect analysis of the product, and I think more and more these products are getting, the from assembly line itself, you can detect, you can give the parameters in terms of these are the kind of the parameters to look at. And if these parameters are to be given through AI, it can do at least 100 times faster than what manually any particular defect detection that can happen over the conveyor belt. And that can reduce losses even in the assembly line. Even if you take this kind of if you take the press metal kind of assembly line which is going in, and if I have a computer vision over there, and using that techniques, I can know where are these micro cracks which are happening, and straight away the robots will take out that defective piece and put it away without stopping the assembly line. That's going to happen, and that's already happening as we see. And a lot of these things in terms of like simulation, you can have this your CAD model uploaded CAD into the CAE, and CAE can get into the CFD, and all those fluid dynamics analysis can be done and simulated before you do the kind of prototyping. I mean, those kind of uh, the advancements are already happening in the mechanical engineering space in which the startups are working.
I'll just try to throw some light from mechanical engineering point of view. So, आपका IT based था थोड़ा सा. So basically, see, good old days when I started my factory and I bought some machines from Europe and started manufacturing, we always used to look at productivity, efficiency, working hours, idle times. We had to just deploy people to keep on measuring everything. But if you just move across, and today the machines which are coming, they themselves give all this data without any human intervention. So these are the points. Like if there is a, I still remember there used to be sliding bearing in one particular machine, which was a CNC machine and very costly. But nobody could identify when exactly that bearing is going to fail. But today, AI, we can easily predict. It can monitor the temperature of that particular bearing. If friction is increased, either grease it or change the particular bearing. So all these things are definitely there to help out for the industry or for a manufacturing process. to work more efficiently and without any interruption, which is the big boon to the society, which I particularly feel.
नाही आता now this question is for all three experts, and question from my side is, what type of knowledge revolution expected in educational institution, academic side? What type of knowledge revolution expected in educational institution to cope up with the changes?
I think the best expert to speak on this is absolutely Shashi sir. But sir, because you are already connected with the industry as well as the institution.
All the institutes.
Yeah, that's why. And see, basically, what I understand, AI, ML, and all these data science technologies are being taught, most of them, uh, either abroad in the US or Europe, and gradually they are coming definitely here also. But what I see is either private institutes or something like that. After doing engineering, people are moving towards it or acquiring those kinds of skill sets. But currently, if you are seeing the change which is happening, last year only I heard that the complete branch of industrial engineering, which was there in one of the colleges, is being scrapped, and now they are completely changing it to AI, ML, and data science. So these types of changing are definitely happening in our own city. So I think the change has already begun, and people are getting it so seriously that changing the complete branch and scrapping it, the old school of thoughts, and coming to face the new learning curves is definitely very good change and a welcome change, I think.
So I think again going back to what we mentioned, and the kind of the technologies which are just coming in any field for that matter, and mechanical is no exception to that. I think challenge for everybody whosoever is learning right now. The most challenging part is we are training the people for the skills which they are not going to be required after 10 years. Most of them. That means those type of skill sets are not going to be relevant, and this landscape is going to be changing every 3 to 4 years, 3 to 5 years. Even if you take the companies in the top 500 space, the average life was 50 years. Now the life has come back to 15 years. I don't know whether the life will come back to only 10 years. And the entire landscape, technology, methodology, all those things are going to be changing so fast. In that sense, the challenge for everyone, including all the students, is not going to be staying ahead of the curve. I think staying relevant itself is a big challenge now, because at the rate at which these technologies are changing, and in that context, we need to sort of like get, if we were to catch up the fast moving train, that means you need to start running right at the early stage, start running at the speed of the train, and then only can hope to catch up that train. And in that context, those building of the skill sets of any engineer for that matter, not mechanical or electrical or electronics, has to start right at the first year, second year level. At, you can't wait for third or fourth year. So the even for the mechanical engineers, because of this kind of the AI technologies and ML technologies which we are bringing, in terms of even designing of the products or designing of the machines, because all these machines are going to be smart, all these machines are going to be connected. They are, as Vivek was mentioning, about a lot of automation which is coming in, powered by AI, which means a very interesting kind of a scenario which we are coming in, which we are saying that uh, AI on or the IoT or robotics on steroid, which is going to happen through AI. So it's not only going to be adding, it is going to be multiplying the effect. So AI coming together with the industry 5.0 is going to have a much more multiplier effect. And from that context, all those machines and all those things are now going to be designed from a perspective whether they are adaptive in terms of whether they learn from the systemic configuration and the kind of the environmental input they get from the ecosystem, and can they adopt to them a better version of themselves. Those are the kind of the flavors which even the mechanical engineers have to be there in terms of requiring, because see, all things are going to be connected. One very interesting example that was given by that how the smart manufacturing, as they say, that the in one of the cities what they did was the whatever the collecting cans, disposable cans, which are put in the corners of the road, and the people can throw their bottles or the coke cans into that, and depending upon because those are the sensor based cans, so depending upon how many bottles were thrown in a particular week by that community, that is sent back to a manufacturing facility. And that's where the manufacturing facility becomes smart in terms of adjusting to the ecosystem inputs. Now, that's where the all engineers, for that matter, have to be equipped with these kind of skills in terms of the predictive analysis, AI, ML skills. I think these are not related to IT now. Just like the cell phones and computers, initially the computers were thought of to be used by only scientists and engineers and computer science people, that have become a regular tool. Similarly, in 5 years of time, believe me, all these AI tools are going to become so sophisticated and so easy to operate, and these are going to be so cheaper. They are going to be available out of the box, and not they are not going to require, even for this purpose right now, if you are going to do a data analytics right now, if you see the co-pilots which are available on the Microsoft platforms, these co-pilots are you're able to interact in the natural language processing and get the analysis of the data. You don't require programming language. It is not the domain of the IT per se. We need to move out, and every engineers would require this kind of common skill sets. And I think what Vivek said, we need to bring in these kind of education, the frameworks, the fundamentals of these educations on this IoT 5.0 and AI right at the early stage.
Yes, sir. Rightly pointed out by Shashi sir. Now, educational institutions are also going to adopt such type of scenario through NEP 2020. You know, there are strict borders in education system now. They are thin, and mechanical engineer can take a minor degree in computer science and so on. So these boundaries are now going, and government is also strictly implementing the NEP for educational institution in this year. Autonomous institution and university adopted institution, autonomous institution mostly adopted autonomy, but from the 24-25 session, every institute has to go for a NEP impacted course. Now I will go to the Kolle sir, and my question is, would MSME industries like fabrication shop, mechanical engineering workshop survive in this scenario? But Thank you, sir. So thank you for nice discussion and uh, inputs or value addition to all of us. I conclude with Albert Einstein's once said, the measure of intelligence is the ability to bring a change. So that ability we have to enhance. And the change is here that the Bharat of today welcoming the leaders of powerful nations and standing here as a host to showcase the true talent of Bharat with pride and humility intertwined together to the idea of Atmanirbhar Bharat and for all of us. Thank you. Thank you very much.
Thank you.
Thank you so much, everyone, for coming. We're honored to have you here. We can now disperse for the break, and we will be meeting in half an hour for the valedictory ceremony. Thank you so much, everyone.
And Dr. J.F. Agrawal. We are here for the valedictory function of 38th National Convention for Mechanical Engineers This convention has seen a lot of technical sessions and very good paper presentations, and it has given us a tomorrow more than we deserve. I request Mr. Milind Pathak sir to give the welcome address.
Good afternoon, all. Here we are coming to the end of 2 days action-packed 30th National NCMC. There were lot many lectures, memorial oration lectures, then ultimately the panel discussion, presentation by sponsors, all knowledge sharing things, action-packed and delivered in a fantastic way. I remember one thing in Ramayana, Ram and Ravan. इफ यू सी देम एज टू कैरेक्टर्स, अगर दो प्रवृत्तियां करके देखें इन्हें, तो व्हाट इज द डिफरेंस? राम और रावण, रावण ज्ञानी था, महाज्ञानी था, लेकिन उसे अहंकार था, और राम, राम को अहंकार का ज्ञान था। तो इसी भावना से, सारी राम प्रवृत्ति से आज जो भी स्पीकर्स हमारे यहाँ आए थे, बिना अहंकार अत्यंत सहज भाव से हमें उन्होंने नॉलेज शेयर किया। हम बहुत उपकृत है। वी आर हाईली ओब्लाइज्ड विद ऑल दी स्पीकर्स, experts, panelists whosoever delivered. We will have the technical report in details. So for this last leg of the function, the validity function, I welcome MSME director, my friend Dr. Parlewar, then chief guest of the function, Uday Kamath, industrialist and alumni of the same situation. From VNIT, Dr. Thombre, Andhare sir, Mahesh Shukla sir, organizing secretary, convener of the function, Srivastav sir, honorary secretary of IEI, JF Agrawal sir, and of course, the man behind this NCMC, chairman of Mechanical Division Board, Dr. Ranga Reddy, and all the good audience. Welcome for this valedictory function. Thank you.
Thank you, sir. After this formal welcome with the words, let us proceed towards welcoming Shri Prashant Parlewar sir with a floral bouquet and a shawl in Shrifal. I request Dr. R.L. Srivastav to welcome Parlewar sir. Thank you, sir. Our chief guest for today is Mr. Uday Kamath sir. I request Dr. N.T. Rangareddy sir to welcome Kamath sir with shawl and Shrifal. Thank you, sir. For a brief report of all the technical sessions, I now call upon Chairman Technical Committee and Head of the Department Mechanical Engineering, Dr. S.B. Thomre.
Good afternoon to you all. Dignitaries on the dais, of the dais. I am here to present a report on technical sessions that happened during this convention. Okay. As far as technical business is concerned, we had 7 technical lectures. Those were delivered by eminent speakers, and 8 parallel sessions where research scholars across the country they presented their work. The first memorial lecture, that is Dr. S.C. Bhattacharya memorial lecture, was delivered by Professor Milind Pathak yesterday on role of AI and ML in mechanical engineering. This was followed by a state-of-the-art lecture by Professor R.P. Monti on future of mechanical engineering. Today we had another SP Luthra Memorial Lecture by Dr. B. Maitri, Director IIM Nagpur, on Industry 4.0, 5.0 applications for mechanical engineering. We also had invited lecture by Dr. R. Venkateshan, Mr. A.P. Acharya, Mr. Anjani Kumar, and Hemant Chaudhary on their relevant topics. As far as parallel sessions are concerned, we had a technical committee consisting of myself, Dr. P.V. Kane, Dr. N.K. Lautre, Dr. Minaj Ahmed, and Dr. Vishal Shukla. We received about 116 papers for the parallel sessions, and the papers were scrutinized for relevance to the theme of 38 NCMC and were checked for plagiarism with and without AI content within permissible limits. Upon satisfactory results, the papers were referred to the reviewers pan India, and all papers were reviewed by minimum 2 reviewers, either same or different reviewers. In all, we could clear 79 papers for publication here, but we received about 58 papers in camera ready version. Total number of papers rejected were 37, that is about 32% rejection rate, which is reasonable for such conferences. During parallel sessions 8 yesterday and today, about 80 papers were presented in physical mode, whereas 20 papers were presented in online mode. In addition, about 5 case studies were also presented during the parallel sessions. The parallel sessions were chaired by Dr. V.K. Viranna, Dr. G. Saiful Islam, Dr. Jignesh Vahadia, Dr. Ganesh Kumar, and Dr. Raja Ramanna, along with Dr. Vishal Shukla, Dr. Minaj Ahmed, Dr. G.K. Avari, and Dr. P.V. Kane. Based on the reports received from the chairman of the technical sessions, the marks awarded to the different papers, they were normalized on a common scale, and we could identify some paper as the best paper. It was a real difficult task. The margin between first and second, or maybe third, it was very, very low. But then the committee has worked out well and could finalize this. The announcement will be made later. I congratulate the authors of the best papers, whosoever it will be, and I thank the committee members and the reviewers for their untiring efforts for successfully completing the tasks assigned to them. Thanks one and all. Thank you.
Thank you, sir. And I call upon Dr. Atul Andhare, Professor Mechanical Engineering, BNIT, for finalization of recommendations.
Good evening to all of you. Dignitaries on the dais and off the dais. I am given a difficult task, I will say, to suggest recommendations out of this 2 days event. As discussed by Professor Thomre, we had a number of expert talks by Professor Atre, Professor Maitri, Professor Monti, Mr. Acharya, Mr. Anjani Kumar, Mr. Hemant Chaudhary, Dr. Venkateshan, and we had a panel discussion also just before this program. Now, looking at all these lectures and the panel discussion, etc., some common points which were observed, I am going to present these points. First and foremost is that mechanical engineering is still relevant. There is no danger to mechanical engineering as such. Mechanical engineering is evergreen branch, I can say. And it is still important because any machine, anything that you want to make new, mechanical engineering is going to be there. Even if you are making a PC or anything that you are going to make. Industry 4.0 or 5.0 has come into use to a large scale. Number of sensors, Internet of Things, AI and ML contents have totally revolutionized the field, how we are working and how the technology is moving. So we have to adopt this technology. There is no option. There are challenges in adapting to these technologies to mechanical engineering domains or machines or systems. These challenges are lack of data, complexity of the data, handling of data, but we have to find ways to implement these technologies to mechanical systems. Technology adoption is the key to success in designing or developing new products or processes in mechanical engineering. And now actually we want to have smart products or smart technologies or smart processes. So we have to integrate, we have to adopt or you have to follow a multidisciplinary approach to use all these techniques. Another important point which was discussed was that all aspects of industries related to mechanical engineering or in general need to become sustainable. This is to shape a better generation that will contribute to the progress and development of the society. We have to focus on creation of impactful even innovations to make difference to the lives of common people. Another important point which came during the panel discussion was that use of these techniques like AI and ML has to be taught to the students, or the students should have the idea of these techniques right in their initial years of engineering, maybe in the first or second year itself. And every engineer, mechanical engineer or otherwise also, needs to acquire the skills to apply these techniques to the respective domains. So that's all from my side. Thank you.
Thank you, sir. Moving on to the felicitations for the technical breakthrough and for showing the prowess in their system and for the unwavering support provided to this 38th National Convention. We wish to felicitate our sponsors. So I'll read out the name one by one and request the dignitaries to felicitate them. Dr. Hemant Warkad from Yantra India Limited. Thank you, Dr. Warkad. There is a memento for Mr. Hemant Warkad. Thank you. Now I call upon Mr. Pranab Ganguly from Bajaj Steels. Thank you, Mr. Ganguly. Mr. Manoj Sarabhai and Sachin Korwane from WCL, Western Coalfield. Thank you, Mr. Sarabhai and Mr. Korwane. Then Mr. Pradeep Mendhe from Moil. Thank you, sir. Mr. A.P. Acharya from Indian Oil Sky Tanking. We had a wonderful session by Mr. Acharya. Thank you, sir. Dr. Sachin Mahakalkar from Meghe Group of Institution. And now to felicitate the winners of the best paper, I request Dr. Thomre to announce their names. Winners of the best paper, best research paper.
So based on the marks awarded by the chairman of the respective technical parallel sessions, which were normalized on a common scale, and then upon deliberation amongst the members, I declare Mr. Pratik Deepak Agrawal and Mohammad Rafiq B. Agrewale, paper ID number 109, to be the winner or the best paper award during this convention. The title of the paper is Aerodynamic Analysis of a Concept Autonomous Heavy Vehicle to Reduce Drag with Consideration of Yaw Angles and Effect of Crosswind Environment. If
Somebody on
present
his
over here,
behalf can collect this award.
or it can be sent by post, I suppose. The second best paper is by A. Bejelwar, C. Sakre, P. Belkhode, and S. Shelare. The paper title is Experimentation and Modeling of Solar Updraft Towers, Approximate Mathematical Models for Turbine Speed and Developed Power. And the third best paper is by Nitin R. Wakode, Dr. Dilip S. Ingole, and Dr. Tharesh K. Gawande on experimental research on cutting parameters optimization in high-speed milling operations. The third best fit. If they are present over here, they can receive the award. Thank you.
I congratulate all the winners in absentia. Moving on, we have guest of honor Shri Prashant Parlevar. Parlevar is IEDS, a director in MSME Development and Facilitation Office, Ministry of MSME, Government of India. Shri Parlevar has completed Masters in Technology and LLB, has a rich experience of 32 years for development of MSME sector in MSME ministry at various places like Gujarat, Assam, MP, Chhattisgarh, Maharashtra and Delhi. He is having expertise in the cluster development, SEZ Act, foreign trade policy and quality management system and has published papers at national and international levels. Shri Parlevar is heading MSME DFO Nagpur and implementing various schemes of ministry for development of MSME sector in Vidarbha. An alumnus of BRC, his alma mater, always welcomes him. I request Shri Parlevar sir to deliver his address.
Thank you very much. Indeed, a pleasure for me to be here. Being a student of this college, I passed out in almost 86, 87 batch and from Department of Metallurgy, and then I did my MTech from Bhopal, MIT Bhopal. That is. Thereafter, during my service only, I did my masters. It is really a good moment today that the Institution of Engineers and VNIT is organizing this conference. And these type of things, when we are organizing, there should be a strong networking with particularly MSME sector. We are already working on strengthening institute industry network. I have implemented one project also in which VNIT was there, German project to strengthen industry institute network. See, industries, they need some people who can guide them. As a person working in Ministry of MSME, which is an apex organization in our country, working for development of MSME sector, I have seen mostly industries. Here, people sitting are working with institutions mainly. But over a period of 32, 33 years, I have seen MSMEs almost in every part of our country, how they are working, what type of support they needed. See, we have published papers here. If we relate those papers, or if we see that those the papers which we have published and the research work which we have done, we should connect these things with industry. It is very, very much required. Unless we implement these things in industry, there is no use of such research work. No. In China, Germany, Japan, what is happening? Recently, I am one more project I am implementing, German project, skill development project. We all know in Germany, engineering industries are highly advanced. One of the reason is that they have highly skilled workers. They have developed a system to generate skilled workers, highly skilled workers. That is called as dual education system in Germany. What happens? A student who is working with industry, he is also learning in institution. So it is a dual education. In 1 week, 2 days, he is working with industries, 2-3 days, 2-3 days, he is learning in vocational institution. So that is called as dual education system in Germany, and that system they developed 100 years back. As a result, what happened? The workers, skilled manpower which they are generating, even graduation, post-graduation level manpower they are generating, which is highly skilled in their segment. Highly skilled whereas in our system, we are focusing on theoretical part. There they are focusing on practical part. That is why their engineering industries are developed and famous worldwide. So there is one project under bilateral agreement in Nagpur cluster. I am implementing that project. It is funded by Germany. I had been to Germany also last month, and we took almost 17 entrepreneurs from Nagpur to Germany to learn those systems, and it's a project of almost 2 years, and we are implementing it. So these are the things which we need to do for MSME sector, because this is the backbone of our economy. MSME is the backbone of our economy, and in coming days, I think we are focusing on 5 trillion economy, and MSME sector is likely to play a major role in that. And if we want to strengthen them, then institution has to come forward. So my appeal and my request to all those are sitting here, we should connect with industries. Unless we connect with industries, we won't be able to get desired results. The patent number of patents we are filing here, we have a number of schemes in my ministry. It's a major ministry which is supporting MSME sector, and we have almost all the support activities which are required by industries. We have subsidies, we have grant in aid, we have clusters, we support for patent, we support for trademark, we support for marketing, capacity building, anything you just name it, we support for that. But unless this research work comes forward, no, we may not be able to excel in that field. So our institutions like Institution of Engineers is there, VNIT is there. There are other engineering colleges. We have ample opportunities to indigenize. We all know once upon a time there more than 80% of our defense spares were imported. Now it is less than 40%. So there are ample opportunities to do research work on indigenization of atoms, so that we can make our country self-reliant. It's the Honorable Prime Minister's appeal that we should make our country self-reliant. Today is a moment of pride because we are hosting G20 in Delhi, and we are presiding it. India is presiding it. So with these type of things happening in our country, I think our research activities should also get focused on what is the requirement of industries. We have one scheme in which the student of engineering college or management college, if he takes up the project of his final year project in consultation with industry, what is required by industry, and if he completes with the requirement of the industry, his project with the industry, then we give them 1.25 lakh rupees to that student. 25% only he has to spend. Up to 1.25 lakh rupees we give it to them. So this kind of support is available. So my ministry always there to support. Even for this event also, this exhibition is supported by us. We are going to give these exhibitors subsidies up to 80% for general, 100% for SC, ST and women. So this kind of support is available. Any of you, if you want any kind of support, any kind of assistance, you just contact our office. Our offices are there all across India. I am looking, recently I was also heading Mumbai, so I used to look after entire Maharashtra. But in other states also, our offices are there, state offices are there, state director like me are there. So you can contact our office and get yourself connected with MSMEs. That is most important nowadays. With this, I thank you very much for inviting me here. Thank you.
Thank you, sir, for highlighting the activities of MSME. We have Dr. N.T. Rangareddy as the presiding officer or the president of this function. Dr. N.T. Rangareddy is chairman and managing director of Legion Technologies India Private Limited. I invite him for his address, sir.
Thank you. I think inauguration already introduction was done, so I thought it's enough. Respected chief guest of the day, Engineer Uday Kamaji, and guest of honor, Director MSME, Shri Prashant Perivarsab, and my dear Pathak Saab, Chairman, Honorary Secretary, and Srivatsava Saab, Convener, Joint Secretaries, and my council colleagues from Institution of Business India, and corporate members, speakers, invitees, and I think all the guests and ladies and gentlemen. I think we are enjoyed from yesterday 2 days this 38th Mechanical Engineer Convention, and I am very sure that all the people who was attended it got a lot of knowledge take away for the 2 days. The wonderful speakers and the wonderful subjects was done. And on behalf of the Institution of Engineers India Mechanical Division Board, as a chairman of All India Chairman, I would like to thank and compliment and congratulate the organizing team for the wonderful arrangements you have done. And I request all the delegates who are here, give a round of applause for the organizing committee. They have done a lot of work. I think this is not a small task to be done in organizing in a All India national conference. And I think I were to my council member give a feeling that we are really any organizing committee member always a smiling face welcoming all of us. I think that is one of the trademark of a Nagapur convention is all smiling faces welcomed you and hosted you and taken care of. Thank you very much for organizing committee team, sir. And in the convention, I was just telling our company slogan was "Sky is not the limit," and above and beyond the sky. I think mechanical engineers, I was only always talked there, but today after listening, one of the great speaker, Dr. Venkateshan, I think not only the sky, we have to see down the earth. So there was a lot of scope and opportunities for the people under the water. I think it is a very delighted moment for all of mechanical engineers, the presentation done by our Venkateshan, that not only the above and sky or a moon or top, but you also see the underground where the water and underneath, we have a lot of opportunities for a mechanical engineers to be done there. And before I just conclude today, Institution of Engineers India, for my director, those who are guests are their chief guests and our guest of honor. A little two points of that. Institution of Engineers is the largest professional body and is one of the oldest professional body in India. We are almost completed 103 years old, and we have 1 million corporate members spread all over 125 local and state centers. And we are today, the most important day for Institution of Engineers is today, September 9th. And we have received a royal charter in 1935. So we are all over India. We are celebrating today Royal Charter Day for the Institution of Engineers India. We are fortunate that our Mechanical Engineering Convention is almost, we are concluding on the day, the Charter, Royal Charter Day for the Institution of Engineers India. For our guests, that Institution of Engineers India is a policy making body or advisory body to the government, and we represent academy, we represent scientific organizations, we represent industries, we also represent the policymakers. So most of the time, whenever we do a conventions and conferences, our recommendations will be given to the decision makers. Today we are fortunate, Director MSME is there, he is representing the government of India, and we have other industries there. And I am sure that our recommendations, what we have discussed today for 2 days, then it will be given to the respective departments and respective policymakers. I am sure our recommendations will be implemented and it will be forwarded to the respective things. And before I conclude, we are in the Nagapur today. I remember we have a most efficient and energetic cabinet minister is here, our Gadkari Saab. So I just want to take his one point what he mentioned a few days back in one of the conference, that all the professions in India, whether it is a doctors or a lawyers or in a company secretaries, chartered accountants or nurses, any profession you take, that all are regulated. There is a registration body. Unfortunately, we have missed. India has missed, and especially one of the reason Institution of Engineers also missed a bus where that we would have become a registration body for all the engineers in India. Somewhat is the only one profession in India, I think not regulated is engineers. And we have almost around 4.5 to 5 crores engineers are there, but we were not regulated by anywhere and we are not registered for anybody. And we practice engineering as than that. We even before even you get your certificate, you call yourself as engineer, you practice. This is not allowed for any doctor. It is not allowed for any lawyer. It is not allowed for any nurse, company secretary, chartered accountants. Why only engineers can call themselves when you are not registered with a professional body? I think the Gadkari sir was mentioning that he is going to bring an engineers bill, and institution of engineers definitely welcomes that. I think institution of engineers is supposed to be a regulator body for all engineers in India. I think if we would have become that, then the institute of engineers would have become 5 crore strongest engineers body in the world. We have a 5 crore qualified engineers serving in India, and that become the largest and strongest engineers body. Should have been institution of engineers India. We have missed a bus, but definitely as engineers we have to should have a regulating body, and institution of engineers look for that. We should become a regulator body for all the engineers who are practicing and who are serving and who are going to become engineers into that. Then only we get our education system will be regulated and our colleges will be regulated, and there's the only one is a engineer can be done anything, but nobody is there to ask him, nobody is there to tell him. And any guy who go to in our Bangalore different places, any guy who is not even 10th standard, he put engineering works, and engineering word is misused, abused, and wherever it comes, and nobody can put a doctor's name and lawyer name with if he's unless he's qualified and registered. I think in the Nagapur we are here, and I request, I think our the leaders who are here who can tell our cabinet minister to help us that he can bring a engineers bill, and the institution of engineers wholeheartedly look for it, and we thought all engineers should come one umbrella, that is institution of engineers India to come. Then engineers will have a voice, and 5 crores voice is become, I think nobody can imagine how strong engineers can speak and tell the government or anybody in the world that we have 5 crores body. With this, I would like to thank again, especially the organizers and all the delegates here. And thank you very much for your hospitality, sir. Thanks very much. Thank you.
Thank you, sir. We have chief guest for today's valedictory function, Mr. Uday Kamath, Director, Ideal Energy Projects Limited, Nagpur, and Joint Secretary, Liberal Education Society. A brief introduction about Mr. Uday Kamath. He has graduated as mechanical engineering with 4th in the order of merit from VRC, now VNIT. He also won coveted Best All-Rounder Award at VRC for his active participation in sports, gymkhana, debate, quiz, and more. With entrepreneurship in his mind, he completed the cost and management accountancy. He served in an engineering company and then switched to academics and was later a member of Board of Studies at Nagpur University. Simultaneously, he teamed up with other first-generation technocrats, Umred Agro Complex Limited, now Sian Agro Industries Infrastructure Limited, and he piloted the business as managing director during its growth, diversification, and turbulent times. He collaborated with Agro Industry Group for co-promoting grid-connected renewable energy, Yash Agro Energy Limited. In 2015-16, all manufacturing companies of the group were consolidated into a single entity, Manas Agro Industries and Infrastructure, with Mr. Kamath heading as an executive director. He has teamed up with other alumni of VNIT in 2012 to form VNIT Nagpur Alumni Association, a not-for-profit company. During the last decade, VNIT Alumni Association has built a very strong alumni base with more than 3,000 life members and 500 sponsors contributing over rupees 15 crores for the cause of their alma mater. The funds are mainly deployed for academic excellence, campus infrastructure, augmenting student amenities, financial support, social obligations, and charity. We are privileged to have you as a chief guest, sir, for today's function. I request you for sharing your thoughts and views with the gathering.
Thanks a lot, madam. I think maybe whatever I heard was a little on the overboard. So, first of all, first, the organizing committee I would like to thank for having me on the stage here. Shri Parlevarji, Shri Rangareddy ji, my colleagues from VNIT, Dr. Thombre, Dr. Srivastav, Mr. Milind Pathak. Well, I'm not new to this venue, but I'm new to this forum. Let me say that because Institute of Engineers is something which I always left it to my very good friends, Mr. Hemant Thakre, Dr. Rakesh Srivastav, and et al. They have been very busy with activities, and I would only say yes to whatever they would say for Institute of Engineers. Coming to the topic of this discussion, I must admit that I missed out very interesting sessions yesterday and today because of other commitments. But whatever I could gather from Dr. Tombre's report on this conference, I would definitely like to read the proceedings if we can be having an access to. That can throw the light upon whatever has been happening and what is likely to happen in terms of emerging trends. Out of the three topics, I must confess I am only familiar to renewable energy. And that's where my association has been for more than, I would say now, about 20 years. My first venture, and in terms of information, I can just tell you, I promoted a soybean processing plant, and that was in year 89-90. That's almost 30 years back. That time, what would be the crop of or crop size of soybean would definitely matter out to the prices of that commodity. And the only way to find out was the Patwari records. The Patwari would go from village to village or Tahsil to Tahsil, and district wise collective data was given to Department of Agriculture to Maharashtra. Then Maharashtra and similar states would collaborate and give it to Government of India. They would publish something. So that was the means of collection of information in early 90s. And we as industry could find that this is not reliable because many times at the end of the season, the outcome would not match with the production estimates which government was coming out. And government had limitations, serious limitations. But alternative source which remedied was USDA report. That is United States Department of Agriculture would survey all the countries by satellites and they would collect data for all countries put together, including Argentina, Brazil, China, and India, all 5 countries. So the reliability of USDA data, sir, at that time was more important than what our government could collect from the grassroots. But this situation changed dramatically over 15 years. And 2005 onwards, we could see the predictions of Government of India were more accurate than what used to come from USD. Maybe that's the first, I would say, underlying symptom where information was being valued, information was being gathered and processed seriously. Cut to 2015, by the time we would have floated another biomass-based power project, grid-connected power project. And we wanted to sell power in open access to some third party. The regulation said you have to give power on a 15-minute demand supply basis. Now we wouldn't know that for a grid connected power plant, how do you regulate it on a 15-minute basis? And top of it, we were asked to project the supply and demand over next 24 hours, next 48 hours. We would do that with some limited success, learn after you fail in some ventures and slowly we could pick up. Then we were told ki you have to do forecasting. Even wind people have to do forecasting, wind power. Now that is something which was mind boggling. 2 years down the line, we could see that Germany, which today almost has 27% power coming from wind energy alone and 45% as renewable energy, can predict their supply of wind energy as accurately on a model which can predict on a 15-minute basis on a advance notice across the country. Now, if you are not able to predict what was the backlash coming, the thermal power plant had to back down if there was a sudden surge in demand for supply from wind side that could come in monsoon periods like in India. So they could learn from long-term models which were based on certain AI and big data, which they could do from 2016 onwards. We are slowly learning that. Maybe 5 years back, about 4 years back, even Indian government stipulated those regulations. Indian industry adapted to that. So I would say the lag between the two systems, what happened in the developed world and India, reduced from 15 years to 5 years. And now we are talking about AI and ML almost shoulder to shoulder with the developed world. So that's where the progress has been, which has been mesmerizing, no doubt. One point which I definitely would support what Parlivar sir said, that if AI and ML and whatever emerging trends we talk are relevant only for big industries, it will not make sense to the people, because MSME is the backbone. I would fully agree. And here I would request him if he can take up that for upgrading the information technology, upgrading the systems, upgrading the manufacturing practices, MSME could be given certain incentives, certain support from Government of India. I think that's the need of the hour. Otherwise, they'll get outwitted soon. So this is only relevant with respect to the topic. I wouldn't take much of your time. That's what I promised Dr. Srivastava. The first thing he said, you have to come and be on the stage. I said, I'm not comfortable with that. That was the first thing. And I said, I won't be able to speak more than 5 minutes. He said, that's why we are choosing you to be the last speaker. Okay. Thanks a lot. Thank you very much for your patience.
Thank you, sir. Your short but enlightening. Hello. Thank you, sir. Your speech is always short but enlightening, and we really enjoy it. Moving on, we wish to felicitate all those who had their stalls. Hello. I call upon the representatives from these companies who had their stalls in the exhibition. Epic Lighting Private Limited, next is Yantra India Limited, Yantra India Limited. Next is Yalamanchali Manufacture Private Limited, next is Superior Weld Mesh Private Limited, Bajaj Steel Industries, Messrs. Onkar Furniture, Western Coalfield Limited, VSP Aqua Mist Fire Private Limited, Sun Engineers Private Limited, VSP Aqua Mist Fire Private Limited, Citron Engineers Private Limited, Suryoday College of Engineering and Technology, Suryoday College, Sai College of Engineering and Technology, Blueberry Semiconductors Private Limited, Meghe Group of Institution, Yantra Shilp Technologies Private Limited, Yantra Shilp Technologies Private Limited, and Vishweshwaraya National Institute of Technology. Thank you, sir. I now call upon some delegates for their feedback. Delegates who have attended the conference for their feedback. Somebody can volunteer. Rashmi.
Good evening. Hi. But 120 seconds is minus this. Good evening, budding engineers and experienced engineers. It is very difficult to speak to the participants whose one leg is here in the auditorium and the other leg is in his home. Very difficult for me to speak. Still, but still, Sister Lakshmi, I thank you. And while I thank you, I want to also thank to you who has proposed my name, my brother Rakesh, man robot behind the screen. You see, if I talk about this feedback, I tell you in two words. You see the photograph who is, you can see there, Bisasaraya. In Gandhiji's long letter, he gave an answer with 5 words. And with that answer, a book could be written, a nation could be transformed. I am that engineer. I can speak even less. So I want to speak in 2 words. First thing, it was organized in standard and style, very much standard and style. But I'm equally very sorry for the organizers. Tomorrow morning they will have no work. But this last time is deducted, okay? And then I see the feedback. I have attended in 2, 3. This is, I think I must tell you because I have attended. You see, that I have attended in some of the sessions, yeah, and 2, 3 boys I have seen, the papers are exceptionally good, exceptionally good. But when I found that they were not begin one, first, and second, and third, I hope that you have not made that Indian system in Indian process in system. So if, I'm really astonished how standard the papers were there. And here also I feel irritated. IOCL and MSV sir, you are here. Your people, Monogly Tool Room, your people are my participants. Sir, I will speak you one simple thing with your permission. That is, gentlemen, I like to speak you these things because I want to speak you because the buzzword has come, artificial intelligence. Do you know who is the father of artificial intelligence? He is John McCart. And you know who is John McCart? I tell you who is John McCart. That is why I want to tell you. Engineers, You please remember that the, the print media is taken out by the film and sportsman, and you are doing a lot of things and your things are not there. Any traces of things, anything you see around, where there is a traces of engineer, presence of traces of engineers, you must remember that. Who are you? I know. I am the engineers who was there in from 1964. I know you are the warriors in the warfield without knowing the direction where you want. You do not know who you are. I tell you who you are. Remember that. You know why I want to tell you? You know McCaggart, why he was known as he was an engineer, computer engineer, New York. He was in New York there, and you know he was considered as the greatest innovator in the world. So I'll tell you in 3 words: from where you have come to where you are, and where you will go. Where you will go. You see, the civilization, the scintillating turn of the civilization was done by the scientists and engineers. They say they do not do anything. You do not know. In 1976, Graham Bell invented telephone. Who are the people? Who are the community who have given this quality and quantity to all people around the perimeters of the country? It is the engineers. You understand? So you are that engineer. So you are what you are doing? You see, the scientist, he invented telephone, 1876. But you worked as an innovator. Remember, gentlemen, and what you have to do? You see, you have to translate. Translate as innovator. What translate? As you are telling the no teaching, sir. I was telling somebody, you don't teach. Teaches is the buzzwords of yesterday. You groom. You give him. So what is that is required? So think what is that? What you should do? I tell you, as as I told you, you are an innovator. Now I tell you where you will go. You should be a translator. What translator? What ideas? You should have a new ideas, newer thoughts, newer things, newer. Always probing. Can I do better? So you have to translate what have you in their mind, and that you should do as a translator. So you are an innovator and a translator. Sorry, I have taken much more time. Thank you very much.
Thank you for your rejuvenating feedback. Any other delegate who would like to share his feedback? I now call upon Dr. Mahesh Shukla, Organizing Secretary, to propose formal vote of thanks.
I stand here today as a proud and grateful organizing secretary to express my heartfelt thanks to all those who have made this event possible. I would start by thanking the chief guest of today's function, Dr. Engineer Uday Kamath sir, Director Ideal Energy Project Limited, our guest of honor, Shri Prashant Pallevar sir, Director MSME Nagpur, Dr. N.T. Rangareddy sir, Chairman MCDB IEI, for presiding over the function. Our sincere thanks to Dr. Bhimraya Maitri sir, Dr. Venkateshan, Mr. A.P. Acharya, Engineer Ravindra Kohle, Engineer Sashikant Chaudhary, Engineer Vivek Deshpande sir, for delivering their invited lectures. Special thanks to Dr. Manoj Daigone, Joint Director, Technical Education, Regional Office Nagpur, for moderating the session. We thank directors, principals, delegates from all colleges for participating. Thanks to all our sponsors and to all our exhibitors. Thanks to Dr. P.M. Padole sir, Director VNIT, Dr. S.B. Thombre, HOD Mechanical Engineering VNIT, Dr. Atul Andhare sir, Dr. Nitin Kumar, Dr. Prasad Kane, for all their assistance provided for the event. Thanks to Dr. Engineer Milit Pathak sir, Dr. J.F. Agrawal sir from IEI for providing the assistance, and Dr. R.A. Srivastava sir for initiating this event. I thank all the council members for joining the event, and Dr. Minas Ahmed, Dr. Hemant Betule, Shri Jayan Joshi sir, Ajay Motiwalji, Professor Rajesh Bodke for all their hard work for making this event a success. I thank Dr. Mangesh Kotamkar sir, Dr. Meera Dhabu, Dr. Rashmi Uddin Wadikar madam for being the master of ceremony in various sessions. Thanks to Shri Prakash Kulkarni ji, Umesh Pajgare ji, Sudhir and Shreya Sakhore and Deepak for the office staff of IEI for their continuous efforts throughout this event. Last but not the least, I would thank the technical support team of ENIT and student volunteers who worked hard for us, and also the caterers and the stall owners for coming here and joining this event. Thank you so much.
I request everyone to rise for national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
high tea has been arranged, so I request you all for to join for the high tea. Thank you so much.